Yeah. What? Oh, wow.
I can't decide. Your love is sending me round, thinking out loud. Baby, come, let's get down. I can't decide. Your love is sending me round, thinking out loud. Baby, come, let's get down. I can't decide whether we should try and make it work. Far too much wine. I know that we should take the day off work. Ooh, baby, let's groove it out. I wanna see you smooth this out. Let's take it round and keep it moving all night. Ooh, baby, just take it down. I wanna see you spin around. Let's take it down one more time, 'cause baby, I can't decide. Your love is around.
Okay, we are getting ready. Here, majority. I'll just let you know that by the end of the year, I will be recording a very short video for the social media purposes. I will not record our boards and everything, okay, I'll just pass around, but for you not to feel weird that I heard. That's it, we also have 2 breaks after these 2 groups. So there will be a little bit more time to align and also to take a break, okay? Yeah, so that we all arrive by the end of the day.
Recording in progress.
Ready? Prezerv team, are you there? Yes. Yes, yes, we are ready. Yes. Okay, we are waiting for AI. Will be in this page 34. And we continue with asset optimization. That will be the last. So
Hello, everyone.
Hello, hi. Great to have you. I know that the two of you are involved in the presentation due to some technical situation, but it's great to have you here. Congratulations on being tops in the top 60 of free electrons 2025. We are all here, a big room, 30 of us here, all the utilities present, ready to listen to your presentation. Please share your screen whenever you are ready. We will be counting 6 minutes for the presentation, and you can start when you're ready.
Okay, thank you. If you can go to the first slide, Kristen. So thank you, everyone. Thank you for inviting us and for selecting us. So just a very quick intro overview into Keen AI. We founded in late 2018, early 2019. We now work with all the transmission operators in the UK. We've done lots of work in machine learning and AI. We've processed over 700 million images. We work in two areas. We're looking at condition assessment, but also the implementation of AI and machine learning into how you plan for the new grid and new networks, right? So we, like I said, processed over 700 million images. We've been going for more than 7 or 8 years. 2 innovation projects have always gone into BAU. And this year, we're also working with Google to partner on the Google Street View data to allow for pole-to-pole connectivity. So if you just kind of flick onto the next slide, Kristen, if that's okay. Our core products are around 2 areas. One around condition assessment, which is deep steel haystack superconductor that you might have seen in some of our materials if you've seen them already, but also intelligent connection explorer, which is ICE. How do you plan the network? How do you do route planning, costing, and demonstration? There's a QR code there if you want to see some further materials on that. Today, having read a lot about the utilities involved, we felt the most relevant product was ICE, and we can talk about what that problem solves. So if we just move on to the next slide. Fundamentally, what we have here is there's a connections overload. So globally, what we're finding is that there's a massive need to triple the amount of renewable generation attached to the networks, but also as part of electrification, we need to add even more capacity to the network. But what that's causing is increasing delays in getting connected to the grid. Both grid operators are being overwhelmed because they don't have enough system design engineers, and project engineers or project developers themselves are encountering delays because they don't have enough. They maybe don't make the right decisions right at the very beginning of the process, so they end up with planning delays and having to tackle reinforcement issues. So what we try and do here with the Intelligent Connection Explorer is a tool really that combines both the calculation of grid capacity, what available capacity is, route planning, timeline, and estimation in a single tool that an operator and developers can use. And just fundamentally, what I'd like to point out is this is going live into Iberdrola and Scottish Power this end of April. We trialed it last year, and it was a very, very successful trial. And Kristen is just going to go a very, very quick demo of that at the moment.
Do you want to carry on, Amjad?
Okay, no problem. Thank you. So here, what we can see is what we have is if you look on the bottom right-hand corner, what we have is you have a legend that shows you the available substations on this network. So existing means these are substations that already exist on the network. Contracted means substations that are in planning of being designed and built. They've been contracted, but they don't exist yet. And proposed is what system design and substations are considering to be built. So if we can just do a search, Christian, on a new connection, so just add in like a connection. So create a new connection, say 52 megawatts, 132 kV, and drop a pin somewhere. So you can just. So what this is doing, it's running a search across all the available substations and saying, okay, these are substations that have capacity. Then it ranks them based on the closest one. So if you drop down on possible substations, it shows you the ones that are possible. And then what it also does, it says, okay, these are the available substations, these are the available capacity. Can we just drop down an estimation, Christian, if you don't mind? Sorry, estimation. So here we've done a couple of things. One is it's told you where in the substation you could connect, what busbar you could connect to. It's also generated a cost breakdown in terms of what the cost would be for connecting to that particular substation from where you are, and also a timeline. So this data is derived from a number of things. The system has an underlying model of the network, so it runs a power flow. It also has either charging statements from transmission operators to say, okay, this is how much each individual component costs, and also historic data on how long connections typically take. And what it's also generated is options for what an overhead line routing would look like. So it has what's called a tension map that looks at all the different routes that an overhead line system could take. And then it says, okay, this is the best route. So you can never go and connect as the crow flies. And one of the things that we're trying to address here, how do you connect to the closest connection node, but also kind of understand and mitigate any potential issues you might have with connection, like planning. It avoids built-up areas, it avoids water and things like that, right? So that's the product. And if you go back to the presentation, what we can talk about here is just kind of a recap on what this does, right? So it's a fast tool. Its USP is it combines both network capacity, so it has a network model. It combines the understanding of where routes need to go and historic data of cost and time to give a very, very rapid view of where you connect. And it can be used both by system design and also by project developers, right? And it runs very, very quickly. So we have cached ways of doing things, but that's the solution. It's a kind of a co-pilot for system design and new connections. In terms of the roadmap, we're also building this year and later this year and later on, we've been talking to the Department of Energy in the US and DARPA-E around, not only does it look at the existing network and what's planned, it suggests how networks could change to accommodate for new requirements or new load. But also one of the most important things that we're finding traditionally is that the loss of inertia from traditional generation means that there's an impact on grid stability. So the underlying grid, the capacity models can now also simulate the lack of inverter-based resources and what that means. And if we can just go one further slide, in terms of implementation and next steps, pilot rollout in 8 to 12 weeks. A lot of the source data is either publicly available or the operator has that already, i.e. capacity and network estimate. So we can take extracts from Power Factory and things like that to generate this, and also work with you to see how you could adopt and maintain this within your organization. So that was a brief introduction to what we do and the Intelligent Connection Explorer. And there's a QR code again if you want to connect and download any material regarding some of our other products. So thank you, and thank you for your time.
Wrap up part of the presentation. Sorry. And let's go to the questions right now.
Thank you.
Hi, Samuel from Eon. Thanks for your presentation. I'm really nice to have you here. I'm curious how easily we could adapt and use your solution in other European markets in terms of data availability. So what you need from us to get started, let's say in Germany or in Eastern Europe?
So for the route planner, a lot of the data is taken, I guess, from things like the open infrastructure map. A lot of the planning of the routes is kind of publicly available data. Time and cost is typically provided by suppliers in the UK or operators with have official charging statements that we can use. The only thing we'd probably need to work more closely with the operators themselves is a more detailed understanding of what the network looks like. So in the UK, we have a GB energy system design. So we were able to access the publicly available data from the system operator to generate a power flow calculation. We'd need to work with you to understand exactly if the situation is similar in Germany or in Europe, right? I think there is a lot of open data initiatives. Actually, Europe is much bigger on open data initiatives than in the UK. So I hope that would be something that we could be able to do. But that's something we would need to investigate, specifically with the German market.
Okay. And do you also include socio-demographic data to do your calculations? Do you also feed that in your model?
So the underlying, I guess when it comes to capacity and looking at network flow, we do not, it's purely electrical calculations in terms of, can the network be installed? Can the capacity there, where would it go, etc. When it comes to overhead line routing, the routing algorithms look at things like, is it a built-up area? Is it crossing? Is it affecting like areas of biodiversity and things like that? And they have different weightings in them. I don't know if there's a layer that looks at socio-demographic. I'm not so specifically what that might mean, but we do look at the environmental impacts. We do look at the impact on built-up areas and communities and try to avoid them when you try to route something and you rank them appropriately.
Yes, just a quick comment as well. We don't necessarily measure directly the social impact, but we do measure proximity to houses and built-up areas and proximity to roads. So we could perhaps build on that to create a deeper understanding of the social impact.
Thank you.
One question, this was mainly about the Intelligent Connection Explorer. I was a bit surprised because I saw in your deck also the other solutions. So what's your current focus, or are you just tackling like these different issues?
So it's a really good question, right? So our initial focus was doing visual inspection, using machine learning and AI to visually inspect transmission assets, right? But as part of our work, our customer said, our biggest problem now is, you know where all our overhead line networks are, you know where our substations are. Can you help us do the planning in terms of how we might build and develop that network and inform our developers? So I built that. And today, the reason we spoke about this, we needed to choose one in the 6 minutes time that we had to talk about a project that we have that's very relevant to you. And based on the reading that we've done of what like CLP, E.ON, the operators from Australia, that seemed to be the most pressing challenge. So we felt it was relevant to discuss it today.
Thank you.
Our time is up. Thank you very much for your presentation. It was absolutely great to have you. Congratulations.
No, thank you guys. Thank you ever so much. Thank you for hosting it as well. Bye-bye.
Thank you.
Have a good rest of the
Bye-bye.
day. Thank you. Very good. Let's go to starting number 22. It's FulcrumAir. And we are waiting for William, who will be dialing from Canada. Oh, I'm just, you're still here. If you would like to.
I've quit.
Thanks a lot. Bye-bye. Page 27, if you're looking into the books. Hello, hi Will.
Hi, everybody.
Great to
Thanks for having me.
welcome to the peak room of free electrons, and congratulations on being in the top 60. We are all here, more than 30 of us in the room. Looking forward to get to know your solution better. We can see your screen very well. If you are ready, you can start. We will count 6 minutes for your presentation.
Excellent. I'm ready. Thanks for having me. So I'm Will from FulcrumAir. I'm here to present our aerial robotics solution for revolutionizing grid construction. We're excited to present how aerial robotics can help achieve what we're calling, and many others, near impossible task of the grid expansion ambitions in the coming decades. So a bit about the scope of the task at hand. There's a number of worldwide mega projects that governments around the world have aspired to complete. Some examples here, we have Australia. There's the Queensland Energy and Jobs Project. It's a Australian $62 billion investment from 2022 onwards, aiming to complete about 950 miles of new transmission lines. We're actually working on this project with a small contribution installing bird flight diverters. Further, the UK, they've looked at massive grid scale transmission upgrades across the UK, bringing 50 gigawatts of onshore wind, totaling approximately $77.8 billion of investment. In Europe, there's similar scale investments. Tenant and other major German utilities are looking at a 200 billion euro investment of similar scale, adding approximately 400 kilometers of new transmission lines to upgrade electrical transmission infrastructure. Onto the US, there's other huge mega projects underway. By some estimates, depending on the model of forecasting using, there's approximately 57% growth required just in the US alone by 2035. This equates to approximately 47,000 gigawatt miles of new transmission lines, which is a huge amount given that at the current rate in 2023, for example, there was only 55 gigawatt miles constructed. So the point I'm trying to make is there's a huge scope of new transmission infrastructure requirements in the next decade if governments are going to not only meet the ambitions of net zero transition and electrification, but just maintain the bare minimums of grid transmission, electrical grid requirements in the coming years. The solution we offer is, has a number of benefits. First and foremost is a huge safety benefit, and how this helps enable this type of grid transformation is that safety becomes less of an obstacle to project delivery. Here's some examples of a traditional method versus our aerial robotics solution. We see here a power line technician installing bird flight diverters from the platform of a helicopter versus our UAV and robotics solution doing it autonomously from the safety of a truck in the distance. Similarly, we have a bundled conductor spacer installation being performed from a buggy compared to our CSR robot doing it autonomously and from the safety of a truck. There are huge challenges ahead. The amount of work is enormous. Like I said, to meet this electrification requirements in the US alone, they need to build 3,300 miles of new transmission lines per year. The average of new construction has actually been declining over time, where about a decade ago, it was approximately 1,700. And as I said before, in 2023, they only built 55 miles. So the amount that they need to build is much further behind from where they need to be. There's a labor scarcity as well. We have a shortage of people entering the trade and being able to perform this type of work. And the methods that they use to perform that work are risky. There's safety problems with that. So how robots address that is we can address these labor concerns by reducing the amount of workers required to complete these types of installation tasks. We can increase productivity by doing more with less, and we can remove safety as an obstacle to project completion. The installation methods with aerial robotics can be typically 75% faster versus traditional methods. We're looking at bird flight diverter installation and bundled conductor installation using robotics. They're significantly cheaper where there's a lot fewer capital intensive assets required, such as bucket trucks, cranes, and helicopters. And we can reduce the overall amount of personnel required to complete these mega projects. So what we aim to do is expand the adoption of our aerial robotics across the world. So we've already established a strong foothold in our home province of Alberta, Canada, and we've expanded into the US in the past few years, but we're looking to increase adoption across US utilities and contractors and further abroad into Europe, Australia, and other markets that would benefit from the aerial robotic technology efficiency upgrades. So we're looking at our two main service products are the Linefly, the bird flight diverter installation robot, and the CSR, which is the bundled conductor spacer robot. Bringing those to other markets, building more units, and continuing to offer this service across different utilities in other markets around the world.
Bill, perfect. Right on time. We see the call to action, but I suggest we will move to questions right now. The 6 minutes
Okay.
passed, but we have 4 more for questions, so we can start right now.
Yeah, so I can start. Thank you, Will, for the presentation. Andre here from EDP. So you have, I'm not sure if you have a slide there with the 5 different products that you have that are on your pitch deck, but maybe we could have some overview on each one of them. And we have 2 or 3 questions for each. I'm not sure if we'll be able to cover most of them. But maybe we can start with the CSR. How do you put it up on the line, and how does it jump from one span to another?
So currently what we do is we set up at one structure and we can deploy the CSR on either side. So we can reach 2 spans from one structure. And we do that while they're doing the clip-in phase of the line construction. So we're setting up with a bucket truck or a crane and deploying the CSR that way. We have in the prototype phase right now a flying version that uses the same technology that our Linefly, the bird flight diverter installation robot, uses to land on the wire and install the components without requiring a bucket truck or crane to set up at the structure.
Okay, very good. Now, looking into the heavy lift UAS, what's typically the load that it can carry? The battery time, how long does it last? And what are the main use cases that you have been using that robot for?
Sure. So the heavy lift drone that we developed is the E2500 HP. It's specifically designed for lifting these power line robots into the power line installation environment. Its max takeoff weight is 25 kilograms or 24.9, and that's by design to fit in with the regulatory frameworks. So above 25 kilograms, it becomes significantly more challenging in terms of regulation. But under that threshold, it fits into the sort of easy to operate and low permitting requirements that most countries have in place. We have developed a 110 kilogram max takeoff weight UAS that we can use for other types of heavy lift power line applications. But right now, our sort of niche and sweet spot is that sub 25 kilogram weight class.
Okay, very good. Then looking at the Linefly, our question is really to understand how easy is it to adapt to different accessories, and what other type of bird flight diverters it can be combined with.
Sure. So currently we're installing the 2 most popular types of bird flight diverters in North America. One is called the Powerline Sentry Hawkeye, and the second is the Preform Line Products Spiral bird flight diverter. Those are by far the 2 most common. We have performed a demo in Germany where we've been looking at adapting it to install the more common type used in Europe, but what we've tried to focus on is increasing adoption of the ones that we can already install, because the reason we selected them is because they are suitable for robotic installation more so than the other type, and they are effective bird flight diverters.
Any question here in the room? If not, then my final question is regarding the lead line stringing. And how is it different from other competitors, and what type of cable do you string?
Sure. So how it's different from other competitors is we can offer a package service where we can perform other robotic installation tasks in the power line environment simultaneously while reducing the mobilization requirements, dealing with multiple contractors. We can offer a package solution where we're installing bundle conductor spacers, bird flight diverters, and doing lead line stringing. What we're doing now is we're pulling a Dyneema pilot line to then go through a pullback winch and pull the lead line, which eventually will pull the conductor through the traditional spooling drums.
Very good.
Thank you.
Stop
Thank you.
here. Will, thank you very much for your presentation. This lot always passed very quickly, but thank you for all the information that you shared with us.
My pleasure. Thank you for the questions. That really flew by.
That's everything for today. Thank you very much.
Thank you.
You can click to leave the room in the bottom right of the Zoom call.
Oh, okay.
And that's it. Okay. Here we are. I see we have more people online. Great to have you. If you have any questions, you can always write them in the chat. And we are waiting for the startup Linebird. It will be Michael, page 36. And those are last two startups in asset optimization. Hello, hi Michael. Great to see you again.
Great to see you as well.
So right now you are in the room, in the pitching room. We are more than 30 here. Also many people online to see your presentations. We are ready. So whenever you are, you can share your screen and start. We will count 6 minutes on the clock, okay?
All right, thank you all for being here. Let me get the screen shared momentarily here. All right, is that working okay for everybody?
Yes, we can see it well.
All right, shall I begin?
Yes, go ahead.
All right, well, thank you everyone again for being here. I'm Michael Bayro, President and CEO of Linebird, and today I'm inviting you to join us in transforming how work gets done on the grid with tools that will help make work safer and enable a more electrified future. Now, you all are no strangers to this, but working on the grid is quite difficult. Being the boots on the ground operations is one of the most demanding jobs in the developed world. And you can see, just a few examples in these pictures here. You already know this, you know these numbers as well. In the US, it's one of the most fatal occupations we have here. And there's also quite a need for additional workforce in this sector. There's lots of work needs to be done in transmission and distribution infrastructure. There are not enough qualified workers already, and the age demographics of the workforce are not looking good for the market overall. A new influx of workforce augmentation and also new segments into the workforce are needed. And overall, that work of accessing those lines is dangerous, expensive, and labor intensive. So the way that we solve for this problem is by selling drone payloads to utilities and their contractors solving for power line access. Our flagship product is the Osprey non-conductive payload system, which is in this black box here is our product, as well as the end effectors below. This bolts on to an off-the-shelf professional grade drone that you may already be using for LiDAR or line string operations or many other applications. It's far less costly than helicopters, more cost efficient than bucket trucks, enables you to reach lines on about any terrain with minimized risk to your crew. There's a direct climate impact to what we do by mitigating emissions from fossil fuel burning aircraft and ground vehicles, but indirectly as an enabling platform for many other technologies in dire need of a better way to deploy on the grid. We think we can do some real good at gigaton scale carbon mitigation. Now, against the status quo, the easiest thing to remember is that lighter birds mean lighter bills. And so already gave the comparison against the helicopters and bucket trucks, but the other closest competitor technologically to what we do is companies using custom drones for specific use cases. These are often very expensive projects, expensive pieces of equipment that are typically done as a service provider model for 1 to 3 use cases. We have a different philosophy. We say that we're creating a gold rush and selling the pickaxes, the hammers, the nails, and everything in between to train and equip the workforce of the future. And it's adaptable to many of the existing lineman hot stick tools that exist today. A few examples already of some of those technologies. Companies doing X-ray inspection using drones or installing bird diverters onto shield wires that are not energized. This is a product, you can purchase it, you can lease it, you can bolt it onto your drone, and you can work it up to 500 kV transmission lines as well as distribution lines. I've got a little bit of video here. I won't scan through the whole thing, but just to give you an idea of what we are doing, what we have done in the past. Let me know if this is coming through okay, if the video quality is all right. I may give it a minute to, there we go. So this is a hand line replacement operation, moving material off of the towers for line crews. You can move emergency equipment, supplies, things like that down as well. And so a couple of examples there. We have other use cases in wire cutting. So for storm response, this is a big one that we were asked to do after storms or during wildfires. Cutting power to burning buildings is quite important. And we can do this from the air. So these are existing lineman tools that have been adapted for drone use. This is another one. We have a debris remover grapple, originally for bird nests, but also can be for other debris on power lines, balloons, you know, rodents, whatever you might need to remove from your grid. We have another application in spraying and lubrication. So this could be for switches lubrication, insecticides, de-icing materials, many other applications. Lastly, apologies for the sound there. Let me mute that. Just a moment. There we go. And this is our first use case, is the micro ohm meter for testing connectors, compression splices, and dead ends. This is on a distribution wire here, contacting high voltage. And this is on a transmission line for a project that we wrapped up with a utility in the Northeast last year, testing dead end connectors. Now, I will quickly move through the rest of the presentation here with the time I've got left. The total addressable opportunity we have here, we've mapped this out on an example utility over a 110,000 kilometer service area with 10 line crews. With those crews, you could have up to 50% fewer hazardous man hours by reducing the amount of climbing and energized work that must be done. 60 to 75% lower hourly cost versus bucket trucks, which in the US cost about $10,000 a day, not to mention helicopters, which are $30,000 to $50,000 a day and a scarce resource, and can be 2 to 10 times faster in the field, depending on how it's deployed. If the trucks, for example, would require matting or special grounding, whatever the SOPs are, the drone can be much simpler, you know, 2 or 3 people, pick up truck, unbox the drone, get in the air, get to where you need to go, get back down. We've built strong relationships in the industry over several years. We've worked with Dominion Energy, EPRI, many other utilities. We're an awardee of the National Science Foundation grants, almost $500,000 there. Many utility patents were patented in the US, Australia, New Zealand, pending in Brazil, Europe, and many other places. TRL is 8. We've proven the technology works for quite some time. ARL is 4. We've got on the adoption scale, it's you know, quite a long cycle, as you all know, and we'd be very excited to partner with you all in pushing this forward and proving out and validating the return on investment that you all can receive from things like this. The pilot project that we're proposing is $11,000 to $65,000 for up to 6 weeks of tests plus travel. This could be Linebird's own personnel or a local operator flying, depending on your country's regulations and what speed you want to do the project at. That may be the preferable option. We can train pilots for $1,000 to $2,000 per pilot. And I believe I am at 6 minutes here, but this is the pilot and that's the last slide. So we're right on time.
Yes, we can leave this slide, Michael. And right now we will move to questions. You'll have extra 4 minutes.
All right.
Hi, Michael. This is Maxime from Hydro-Quebec. Congratulations on making it to the top 60.
Thank you very much.
Happy to e-meet you, fellow Canadian. Are you open to selling the NVS and letting us fly with it?
That is precisely our business model. We aim to be a tool and equipment manufacturer and provider.
Okay, that's good. How much would be the equipment at scale, say, when you are ready to sell it on a regular basis? What's your target?
Yes, so initially, depending on if you also require the aircraft, this could be high 5 figures to low 6 figures. And initially, we're doing more cost plus pricing. Once we validate the business proposition, we move more value-based and again, probably in that mid to high 6-figure range for overall equipment, but you can also lease for 4 figures per month. I believe the most recent order we did was a one of everything, which a utility got for just about $25,000.
Okay, you're talking Canadian dollars now.
Yes, although that did not include the ohm meter, which is the most expensive end effector.
Okay, good. What's the voltage level, the maximum voltage level that you've operated at right now? And have you, and also the second question is, have you done bundles?
Yes, that's a great question. So we have flown on 500 kilovolts multiple times. If you give us an opportunity to test on 765 kV, we have full confidence it will work there as well. And we have done single, twin, and triple bundle conductor, and it's been designed to work in quadruple bundle as well to reach all four strands of a quadruple bundle.
Okay, awesome. For your dead end splice own measurement, resistance measurement, how do you go about doing this? Because this is not so easy. I think from an operational standpoint, you are very close to a structure. Is it by using a very long rope, or how do you work around all the obstacles around or nearby the dead end?
Yes, well, I'll just show you the drone's person view that we had a little earlier here. Let me make sure the audio is muted because there was some unintentional audio there, but this is the operation. So here you can see from the ground view what it is doing. We have this, it's a flying hot stick essentially. So we have this harness that we've designed, which is fully dielectric. It will pass all hot stick tests, and it reaches right in and accesses from above right now in a modular fashion. So you can have a different number of segments depending on what your clearances are, what your voltages are, and your expected load on the line to reach into that infrastructure and access dead ends and mid-span sleeves.
And would this work also at a very high voltage level, like a 735 kV, for instance?
I'm a mechanical engineer by training, and I'm confident that it would work. We have done 500 kilovolts several times, and would love to test 765 as well, and 700 and above.
How about wind? What's the wind limit, wind gusts when you operate this NPS?
Yes, you did your homework. So that's a very key consideration in this. We typically we do not recommend our customers fly in wind gusts above 15 knots, or no, I believe that is 15 miles per hour. Apologies for the American units there. But steady winds are not so difficult. We can compensate for that up to decently high winds, but wind gusts are typically the deciding factor on a windy day of whether you want to wait to fly early in the day, late in the day, or another day.
So thank you, Michael.
Very good. Michael, thank you very much for your presentation. The time is up, and that's everything for today.
All right. Thank you very much, everyone. Looking forward to hearing from you. Hope we can speak to your art departments about narrowing in on your use cases soon.
Exactly. We also hope for that. Have a good rest of the day, and let's be in touch.
You as well. Take care.
Thank you. We can already, okay. Okay, let's go to the last one of asset optimization, and as well, the last one for this group. Matthew,
everyone.
Hello. Hello, Andrea.
Hello.
Hi, Andreas. How you doing? First of all, congratulations for making Free Electrons 2025 top 60. That's no mean feat. Well done. You have here a room full of eager utilities wanting to know more about your solution. So as you know, you have 6 minutes to pitch and then 4 minutes for Q&A. So whenever you're ready, the floor is yours.
Great. Thank you, guys. All right. Yeah, my name is Andreas. I'm the CEO and co-founder of Nomadic Drones. We built a new generation of autonomous drones that's able to land and recharge on power lines, which enables our drone to essentially fly for months at a time without human intervention. Today, the team consists of me and my co-founder, Latence, and we met while studying at UC Berkeley in California. I have a background in computer science, and my co-founder has a background in mechanical engineering. And on our advisory board, we have backgrounds from both sales, but also from energy divisions at Siemens. What we're tackling is we're trying to help utilities face the massive pressure that is today of both wildfires and blackouts, but this affordability perspective of maintaining assets. We see today that inspections are traditionally done, with patrols and by flying by helicopter over, but these methods are quite expensive. They can be dangerous and definitely slow. And we've seen improvements in the usage of drones, but drones still have this limitation of needing people on the ground close to the wires. And typically what we see during a drone inspection is this kind of process here where, you plan out an inspection plan, maybe you hike or drive first to the location and then hike up to an access point. Then you need approval, then you deploy the drone, you navigate it and fly and take the pictures that you need, and then you need to land and recharge or swap batteries. And this goes on and on with people on site, which steals a lot of time. So what we've done is we've developed this drone which does all of this autonomously, and when it needs power, it just lands on the line and uses the electromagnetic field from the lines to recharge. Then we process all the information that's taken from the drone, and it's synchronized with our servers where we apply machine learning to help utilities review and assign tasks afterwards. So how it works is essentially we have a pre-planned route, which is waypoints around each tower. Then we take pictures of the different assets. We navigate when we need battery directly above the line. And then we use our radar system to navigate and find the power line and then land safely on it. Then we use power harvesting from the electromagnetic field generated by the currents that's passing through the lines. And then we use this magnetic field as a charging mechanism for our drone, kind of like your wireless charger for your phone, just very much lower frequency. And then when we're recharged, we just take off and continue this. And because our drones can operate by themselves completely, we can speed up and increase the scalability of inspections, both increasing frequency, but also kind of how much you can tackle. So this is kind of what a pre-planned route looks like. Then one of the kind of discoveries that we did when we started talking to a lot of utilities was that from an operational standpoint, it's quite a big task handling a massive data load when you kind of dump thousands of pictures in the lap of operational people. So we try to develop tools that help utilities speed up this review process and this reporting process. So we've developed a machine learning algorithm which takes and uncovers different defects. And we've developed different tools for existing inspections with either drones or with manual patrols or from helicopters to easily report just by talking to your phone, your iPad, or your laptop and describing what you see so that we can automatically write reports for you. It's a big problem, 22 billion. And what we sell is essentially two services. We sell autonomous inspections, and then we sell this asset management software. We have today some pilots. We're working with Vestnets, where we're doing our initial tests. We just did one 3 weeks ago in Leverkusen in Germany. We're working with Elga, the largest DSO in Norway. And then we're moving on also with Amprion soon, later this year, which is a TSO in Germany. We want to offer two different pilot tracks, depending on kind of where in the stage you are and what you're comfortable with. One of the pilot tracks will be the automated inspections, where we capture the right data. We focus on making sure that we inspect and take the right pictures, that the beyond visual line of sight operations work correctly, and line rating in addition to this visual inspection approach. And then on the other hand, we offer this track where we let you use the software platform. We're looking for feedback on how to make sure that from the operational standpoint, it is easy to work with, make sure to solve the right problems, propose the right tasks to the maintenance, and also prioritizing the right tasks accordingly to what the data tells you. The two tracks require kind of different resources. So the scope of the automated inspection track is that we want to inspect 50 kilometers of transmission lines or distribution lines, depending on kind of what you have. We will deploy the drone. We're currently testing it in a high voltage lab, but we'll deploy it and make sure that it works over time as we fly along the lines, and that we can also kind of over time capture the right information and send it back to the operational centrals. The timeline for something like this is 12 months. It's completely negotiable, but we think that 12 months gives us enough time to make sure that we capture all the different challenges of doing autonomous inspections. And we need access and flight permission to fly around your grids, coordination with the grid operations team, and a technical point of contact for this. For the AI accelerated inspection program, we would need, here we want to test specifically the software and the AI that we're developing. So we would need hands-on testing, maybe 3 to 5 inspectors who would be willing to test it in their day-to-day workflow, who would give us feedback on a bi-weekly basis so that we can fine-tune and make sure that we solve all the problems that's needed. We would also need kind of access to your GIS geospatial information system.
Thanks, Andreas. I think we can pick it up in the Q&A, which we still have these for. So I'll open the floor for questions.
Hi, Andreas. It's Kieran from ESB Networks here. How difficult has it been to get certification for BB loss in Germany, European countries?
Yeah, we started talking to the European authorities, specifically in Germany now, and we've been surprised that it's not as hard as we thought. For power lines, we fly in very restricted airspace, so there's little ground risk and there's little air risk. So for getting the certification within Europe, we see that it's probably easier than getting it in the US, because there's a more standardized approach. There's very clear kind of requirements, and we know that just because of like the innovations of like the drone charging boxes that we see, like the DJI dock or the Skydio docks, we know that there's very clear kind of paths on how to achieve BVLOS certifications. So it's not like an easy task, and it's something we're working on, but it's something that's definitely doable.
Perfect, thanks. What are the weather limits for flying in terms of wind speeds and gusts? And then also what happens in storms, and what are the limits when the UAV is docked or charging?
Yeah, so what we do today is we say, when it's a storm, we're just going to wait it out. We stay on the lines. The drone kind of looks like this. In between the legs, there's a charging mechanism which snaps open. It's kind of hard to tell there maybe. But when we're docked on the line, we electromagnetically kind of locked to the power line. So if it's bad weather, which there will be a lot of times, especially now that we're testing in Norway, that's some of the conditions that we're testing extreme cases of, it will be challenging to fly. So we just don't fly when the weather is really bad. Our drone is 2.5 kilos light, so it's pretty lightweight. And that's intentional, just because we don't want to put any risk to any equipment. And for 2.5 kilos, there's no ground risk and there's no really equipment risk either. So for storms, we just wait it out. That's the simple answer.
How long can the drone operate between recharges?
Yeah, so today, it varies how fast it recharges. So today for like 110 kV line, it's 2 hours recharge, which is pretty long. But that will vary based on the amperage of the line. And a flight time is roughly 30 minutes, 20 to 30 minutes. So we think that within that time span, we can do kind of 4 to 5 of the full inspection plans that I showed you the screenshot of. So 45 towers per charge. But that's something that we're playing around with, how to optimize kind of that part, and also optimizing how much battery capacity we should have compared to the weight of the drone.
The inspection plans, are they configured at setup, and can they be changed remotely?
Sorry, can you repeat that question?
So the inspection plans, are they configured at the point of setup, and can they be altered remotely?
So today we pre-plan it, but all of the drones will have data connections. So this is something that we could implement to make them kind of responsive to different missions. That's something that we've heard from other utilities, that they want something that, like, if say we have 50 drones deployed within your grid, then you can respond to incidences and kind of figure out what's happening. But for now, that's like not our immediate concern. We want to do the routine inspections first, and then we can focus on kind of the challenges of emergency kind of rollouts.
Perfect, thank you.
Maybe a very quick question. What type of payloads can your drone have? And what type of inspection do you actually do? RGB, thermal, LiDAR?
So today we just do RGB. but we can switch the payload very simply. It's really just a matter of switching out the camera on the gimbal. So we could potentially do thermal. We haven't tested that yet. What we're planning on working on now is actually a shortcut from doing the visual inspection to just do kind of this DLR system, so dynamic line rating. So one of the requests that we've had from, for example, Vestnets is that we just put temperature sensors here on the drone, which allows them to just deploy the drones as a week-long line rating system, which could give operational teams kind of some information about congestion, and then make sure to adjust accordingly. So that would be one of the other types of inspections or monitoring, if you like, that we could offer. But we have a few different things in mind. First, we're looking at kind of this RGB plus temperature and kind of sag of the line.
All right, Andreas, thank you very much. That was wonderful.
Thank you. Do you know if I just leave this room now or? Yeah? Okay.
There's a button there for you to click on.
All right. Bye, guys.
Thanks, Andreas. Bye.
But yes, we are in the break right now.
Tony.
Yes, we are ready. While we are ready, let's Acculon can Red.
Hey.
It's great to have you. We are very happy to welcome you in the pitch room, and congratulations on making this to the top 60 of Free Electrons 2025. There is a full room, physically and online as well, waiting for your presentation. So whenever you are ready, please share your screen and you can start your presentation. You will have 6 minutes for that.
Okay.
You can see.
Can you guys see me?
Yeah, all good.
Go ahead.
Okay. Well, good afternoon, everybody. My name's Andrew Thomas. I was a founder and I'm the CEO of Acculon Energy, a battery system innovator and manufacturer based in Columbus, Ohio. And our company was kind of ideated in 2021. And at the time, stationary energy storage was exciting. But as you guys can see from the IEA forecast, the size of the opportunity for ESS, whether standalone or coupled with renewable sources, has tripled since then. And that's largely driven by you guys and the people in the room. And so while the adoption starts to get real, and the shape of that curve goes from kind of flat and linear to an S curve or a J curve, the world rushed and did what? It did this. It went to grab the dollars, and you know, there were a dime a dozen companies that hired 50 people, set up an office in San Francisco, and you know, made a deal with a contract manufacturer in China to take this exact same storage container with the exact same features for hardware and software, and deploy these globally. But this white label approach to energy storage missed one thing. It missed this graph. And in energy storage, while it's not quite Moore's law that was experienced in the semiconductor world, it's showing that the technology disruption in the battery space has been incredible over the last 15 years, almost doubling in energy density every 5 years during that period. And my team believed that in that disruption was an opportunity. And so we built a company focused on harnessing this disruption to deliver value to our customers in the industrial and commercial space. And so we built a company not to grab the money today, but to be valuable to the industrial market for quite a long period of time. And so we did that by acquiring not a white label agreement. We actually bought a battery lab and a BMS company that have proprietary hardware and software that, using their testing techniques, produces literally a factor of magnitude greater size of data sets, and in the resolution of the data, 10x to drive a battery management system that enables greater asset longevity and greater asset utility along the way. That informed a modular battery architecture that in a very unique way, we have developed a patented method to make any battery chemistry safe inside of our battery module. And that is what we're making on the far right picture, which is a 1 gigawatt-hour manufacturing line that we're deploying as we speak. So where are we in our life since 2021 to now? We completed a small roll-up of some groups with very interesting intellectual property and capabilities. Since then, we built a $500 million backlog from a strategic investor and other just kind of pure play customers in the low voltage area, where we've launched LFP, and what we'll talk a lot about today is sodium ion products, with those products already going through beta production and out in the field today. And that modular architecture in both the battery management system and in the physical modules themselves are now making our next kind of exciting evolution into your world, which we call the high voltage world, for behind the meter and front of the meter energy storage systems, where we're already taking orders and planning our first commercial deliveries in October. Kind of feels like just a few months away. Questions so far?
We'll have questions in a minute's time.
Sure, we'll keep going. So here's what we'd like to do with you guys, and why. So the first topic, the first product that we'd like to pilot with utilities is a front of the meter solution utilizing our battery management system and our very unique sodium ion product line. Why sodium ion and why our tech? Our tech does something that is not possible with those white label solutions. It enables a BESS container that does not require off-gas detection, does not require fire suppression based on the level of safety that we're achieving at the module level, and very uniquely leverages characteristics of sodium ion technology that eliminate the active thermal management. So you're taking all the HVAC, you're taking all the chiller out of the design of the containerized storage solution. And the value in this we see as up to $180 per kilowatt hour of installed system. There's great data out there from Pacific Northwest National Lab here that has a breakdown that looks at the BOS, or the balance of system, the system integration and the EPC costs for installing stationary storage. This sodium ion solution, where would we pilot it? The focus is in the kind of earlier part of long duration storage. So 4 to 10 hour discharge allows us to passively heat and cool our sodium ion technology. Again, because it's incredibly immune to temperature. I would think about going to harsh environments where it's very hot or very cold, and those are places where batteries are like people. They do not like to live and they do not like to work hard.
Andrew?
Yep.
Can I stop you for a moment? We are already counting the time for Q&A due
Sure.
to the 6 minute pass. So if we could stop right now with the slides and presentation, and I'm sure we have some questions here in the room. Okay? Are you ready?
Yep.
Very good. Let's go.
Fire away.
Let me take 2 or 3 questions. Thank you, Andrew, for the presentation and to introduce you. Acculon, also hi to Tony, which by the way is at the call. And then some questions. Maybe we can start with some of the metrics of your storage solutions. So round trip efficiency, number of cycles, cost per megawatt hour. Where do you stand right now, and what are the perspectives for the near future?
Yeah, so we've done extensive life cycle testing, benchmarking sodium ion against LFP. What we see in the lab under benchmark conditions is 20% greater useful life for sodium ion under certain conditions. That would be one of the goals of the pilot, would be to take not just our lab data, but real world data to create a correlation and identify the value proposition.
Okay.
Go ahead.
Go ahead. So you have there the $500 million in potential customers or potential orders, if I got it right.
Yep.
Currently, how many megawatt hours do you have in operation or contracted by customers?
That 500 million is about an 800 megawatt hour backlog, and the majority of that comes through a 7-year preferred supplier agreement with a Fortune 500 customer.
Okay, and then what's your manufacturing? Do you manufacture your cells or do you externally source them? And then what's your manufacturing capacity for the upcoming years?
Yes, so we are not electrochemistry guys. We are system people. So we source the cells from different suppliers all over the world and manufacture the module and then the cabinetized solution. And our manufacturing capacity that we install in June is 1 gigawatt hour. And in the fourth quarter, we expand an additional gigawatt hour to exit 2025 with 2 gigawatt hours of manufacturing capacity.
Very good. Any question here in the room?
We have still around 10 seconds.
If not, maybe one last question, which is, which sodium battery sizes do you offer or are planning to offer?
We are planning to offer a front-of-the-meter module that is 70 kilowatt hours and then a behind-the-meter cabinetized solution that is 50 kilowatt hours per cabinet.
Very good. Thank you.
Very good. Andrew, thank you very much for your presentation. The time is up. 10 minutes passed very, very quickly. And thank you very much for...
Thanks.
Yes, everybody is very... Yes? Okay. Okay, still here. Good, but I guess both of them already left. Let's go to our plan. Right now, we're moving to gravity power. We will have Steve and also the rest of the startup, apart from the last one, will be from, let's say, North America here in our time zone. Hello, Steve, and I think we have quite big representation today of your team. Great to have all of you. Jason, Jim, Tom, congratulations on getting to the top 60 of Free Electrons 2025. We are all here excited to get to know your solution better. Whenever you are ready, you can share your screen and we will start counting 6 minutes for your presentation.
Thank you very much. I'm Steve Tabor. I'm Chairman and CEO of Gravity Power Incorporated. We're in the business of bulk energy storage. With me today are Jim Fisk, our CTO, Tom Mason, our VP of Engineering and Construction, and Jason Heading. Jason is the Vice President of Hydroelectric at Stantec. Stantec is our engineering partner. Gravity Power is basically a reconfiguration of pumped storage hydroelectric. The way we do it is we dig a deep shaft in the ground, we line the shaft with shotcrete, we put a steel-walled piston in the shaft, we fill the piston with the rock that we took out of the hole, we put in a conventional hydroelectric penstock and pump house, fill it with water, one time only, cap it, and that's the system. So to store energy, we pump water down the penstock, hydraulically lifting the piston. To generate energy, we allow the piston to descend. So it's simple, it's elegant, and although it is robustly patented in several countries around the world, nevertheless, everything that goes into a gravity power plant is a commercial off-the-shelf technology been used in the industry for decades. So what's so good about it? Well, first of all, we project that we will offer the lowest levelized cost of any storage technology. Next, we exhibit very high round-trip efficiency, a little bit higher than pumped storage hydroelectric, comparable to lithium ion. Next, we are very efficient in the way we use land. This is a pumped storage hydroelectric project in Southern California, occupies about 5,000 hectares. And this little blue rectangle here is the footprint of a gravity power plant that stores the same amount of energy on only 12 hectares. And this is an advantage which we enjoy over every storage technology. Next, a gravity power plant is completely underground and completely sealed off from the surrounding rock. So once it is built, there is essentially no environmental impact, negligible environmental impact. Now that translates into very important advantages in terms of deployment, because a gravity power plant is not controversial. That makes it easy to site and easy to obtain permits. It's flexible in terms of where it can go. It has lots of economic benefits for the host communities. All this translates into an ability to scale. We see the energy storage market in 3 different segments based on duty cycle. Short duration is basically regulation and peaking power. Long duration is basically intraday generation shifting from periods of overgeneration to periods of peak demand. And very long duration, that is days or weeks. A gravity power plant is a direct substitute for a pumped storage hydroelectric plant and will do everything that pumped storage can do. Provide peaking power, provide ancillary services, stabilize the grid, and most importantly, daily generation shifting. Gravity power is not a good fit for very long duration storage. Now, we believe that in a fully decarbonized grid, the grid operator is likely to have a mix of storage types, mostly long duration energy storage, either pumped storage or gravity power for daily generation shifting and ancillary services, some chemical batteries for frequency regulation, and some low capex technologies for very long duration energy storage. Right now, we are designing a proof of concept plant and an operational test facility. The design should be completed in about 3 months. What we are seeking today is a utility partner for 2 activities. One is to support the construction of the proof of concept plant. The goal of the proof of concept plant is to demonstrate complete functionality of the gravity power technology in all operational aspects. And we expect to have that done by the end of next year. Excuse me. Secondly, we want to form a working group with our utility partner in Stantec for 2 purposes. First, to oversee the testing of the proof of concept plant, and secondly, to start to make progress towards a commercial pilot plant. The goal of the pilot plant will be to get us past that first of a kind friction in the market and enable us to start to deploy the technology around the world. So what I hope you will take away from this presentation is that gravity power can enable grid decarbonization without raising costs for consumers, without damaging the environment, without wasting energy, without controversy on very small footprint of land, while generating lots of blue-collar jobs, and while readily scaling up to the magnitude of the challenge that we face in decarbonizing the grid. So join us, please. If you have interest, please send us an email or call me anytime. We'd love to discuss with you in more detail the gravity power technology, how we can work together, and how we can get this to make sense for your utility. So thank you very much. I really appreciate your attention. Would love to have any questions that you might offer.
Thank you, Steve. Let's go to questions now. We have some more time. Fantastic. Thanks, Steve. Suchi here from Origin Energy, based out of Australia. Thanks to you and your team for that presentation, and congratulations on getting through to the top 60 of free electrons. So glad we've got a bit of extra time because we've got quite a few questions from our team here. The first is really just the specifications around the actual single shaft arrangement in terms of the energy and power output.
I didn't understand the question, but Jim, did you understand that?
Just do you have the specification?
Excuse me,
shaft, the energy and power.
you're interested in knowing the range of power and energy capability?
Yes.
Yeah, the system works best. It's most cost effective in the range of 3,000 megawatt hours of storage. And so that would be perhaps a 300 megawatt system for 10 hours of storage. But the power and the energy are individually selectable to meet the requirements of the installation. And it can effectively be scaled to almost any size. It's just most cost effective when it gets fairly large.
Okay, and is that then based on a standardized design for the piston and the shaft and just the multiple and the depth that you're going to?
We would prefer to have a standardized or a set of standardized designs, just because that will make the engineering and planning much more cost effective and quick. But again, it can be tailored. The shaft size can be tailored, and the power equipment, the powerhouse, can be tailored to fit the application.
Okay, and I think Steve alluded to the comparison of the area required compared to pumped hydro and other storage technologies, but are there any limitations in terms of proximity of the shafts to each other? Do they have to be spaced a certain distance away from each other?
They would have to be far enough apart to avoid the pressure of one impacting the other shaft. That depends partly on the quality of the rock in the ground where the shaft is constructed. But it's a fairly small limitation. I think they can be fairly close together. And in fact, building multiple units in the same location would have a lot of advantages in terms of construction. And as you know, in big construction projects, the more a construction crew does that same kind of project, the better they get and the faster they get. So having multiple units in the same location would have lots of advantages.
That leads a little bit to the next question in terms of how you control multiple shafts in a single plant to kind of smooth the output from that plant. Have you got a control mechanism that's ensuring smooth output, and how do the pistons operate independent of each other or control?
The power equipment is standard pumped hydro power equipment, except in our case, it works a little bit better than it does in pumped hydro for various reasons that we could go into in more detail later if you're interested. But it's very controllable. You can go from offline to full power in a matter of seconds, 10 to 20 seconds. So that gives you very high controllability of the system, individually or with multiple units.
We've got a call, but please go ahead.
Yeah, but one very quick question. What's the expected cost per kilowatt hour?
So in the United States, we project 4 to 5 cents. There are tax benefits in the United per kilowatt hour. In Europe, the tax situation is a little bit different. So you might figure 5 euro cents. Now that is calculated using the algorithm which is required by the U.S. Department of Energy, was developed by them. It is an all-in cost, including CapEx, OpEx, the cost of the energy lost in the round trip at about 3 cents at a supply. Also end-of-life costs, cost of money, everything goes into that number. And that is a cost of storage. It includes the cost of the energy lost in the round trip, but it does not include the cost of the energy throughput. So for example, if you're buying wind or solar for say, yes.
We're out of time.
Oh, sorry.
Yes. Sorry, thank you for help. Sometimes when I shout here, it suddenly arrives with a delay. Anyway, Steve and Jean, Tom, Jason, thank you very much for being here with us.
Thank you.
Thank you, everyone.
Thank you very much. Appreciate it.
but it was great presentation. Thank you for your time. We will be in touch. Have a good rest of the day. You can already as well leave this room by clicking in the bottom right.
Thank you.
Thank you. Hey, you're waiting right now for SysNergie. I see the whole. Hello. Hi, Julia. Two other team members. It's great to have you. Welcome to the beach room. And congratulations on being in the top 60 of Free Electrons 2025. It's really great to have you. You are 3 in the room. We are more than 30 in the room, so a little bit more, but all excited to hear your presentation. Whenever you are ready, please share your screen.
All right.
And we will be counting 6 minutes on the clock for your presentation. You can start whenever you're ready.
All right. So let's go. So hello everyone. Thank you for being here and letting us the opportunity to present SysNergie's solution. I'm Louis. I'm co-founder at SysNergie here with my partners Felix and Pascal. Let's get right into it. In 2024, the average total outage time in Quebec was 21 hours, up from 17 the year before. Can be explained by 2 major factors: much more frequent severe weather events and rolling blackouts due to lack of power capacity on the grid. And with the demand in electricity poised to double by 2050, and with climate change, this problem is not going to go away. It's only going to get worse. Right now, with limited capacities, and you don't have time to wait 7 to 12 years to deploy new infrastructure projects. And this means that your quality of service can go down. And one of the only backups that you have are diesel generators, which are costly, inefficient, and emits a lot of CO2 emissions. A popular solution right now are traditional utility scale energy storage in the form of large lithium-ion battery that you install on the grid to store excess energy production. They are great, but they take time to install. Yeah, these are big, complex projects and can be a single point of failure in your grid. But what if we flip the script? By installing distributed energy resources in the form of smaller batteries directly at key and problematic sites of consumption to enable some sort of virtual power plant. To improve your outage resiliency, add the ability to have on-site integration of renewables production, less pressure on the grid, and eliminate completely the single point of failure problem. That's why SysNergie has developed OmniTower, a sodium-ion 200 kilowatt power energy storage system that contains no critical minerals, retains more than 70% of its capacity at minus 40 degrees C, is made to be installed outdoors, has a proprietary intelligent management system to enable maximum efficiency and gains on the grid, is completely modular and scalable to your need, budgets, and timeline, and is extremely environmental friendly by being 25% lower in CO2 emission than traditional lithium-ion solutions. Compared to an equivalent diesel generators, you're looking at around $7,000 per year of savings per unit replaced and 19,000 kilograms of CO2 per unit per year. It has a completely instant response time, no maintenance, and it is completely silent. But we don't just sell batteries. It also comes with its complete cloud ecosystem to help utility managers to easily access information about your assets for a total control and much better predictability. Our state-of-the-art algorithms allow you to monitor all of your assets, make better predictions, either for events or maintenance to reduce costs and have better service for your end users. If we imagine this at scale in your grids, that would mean that we could accelerate your net zero objective by reducing hundreds of thousands of tons of CO2 emission per year, facilitate the renewables integration directly into your grid with on-site production possibilities, 10 million plus in savings from reducing outages, better grid stability, and just less energy losses. And in the end, new revenue streams by having dynamic pricing and energy trading. The pilot plan that we propose today is a deployment of 10 OmniTower units in an industrial neighborhood. The first key objective for us is to validate the performance of sodium ion in real operating conditions. Then we also would like to validate that our management systems of distributed energy resources work and prove that the technology is scalable and validate that the business model is sustainable. This pilot can be deployed in less than 6 months while following these simple steps. The roadmap actually looks like this. We currently have a proof of concept that is working. We have one pilot project ongoing with the utility of the city of Magog in Quebec. We have another pilot at the end of 2025 that is also in negotiation. And we would like to have one or more pilot project with free electron utilities of about 2 megawatts at the beginning of 2026 to allow us time for deployment, data gathering, and make sure that we are then ready for certification before we start our production at the end of 2026, beginning of 2027 to allow the scale up. So today, what we ask of you is a conversation with your grid operation team to make sure that we can understand their need and problem and make sure that their product meets their requirements, and a commitment for a pilot deployment with us for 2 megawatts. The opportunity to test and showcase how OmniTower performs under real-world condition is extremely important to us, and it's not a question of if the transition will happen, but how fast can we make it happen? Are you ready to take the next step with us? Thank you.
Great, thank you very much for the presentation. We can already move to questions.
Bonjour, Sylvain Labonté, Hydro-Québec. Tout d'abord, félicitations pour avoir fait la coupure pour le top 60. C'est vraiment un bel accomplissement de votre part. Donc, félicitations. Oui. And that said, tell me, what is your plan? Do you want to position yourself as an integrator or a battery manufacturer?
Very good question. Thank you for asking. So right now, as of right now, SysNergie is a battery manufacturer. So we already produce batteries for critical applications. So for instance, we have a contract with the Canadian Coast Guard to supply them with lithium-ion batteries for the navigation buoys of the St. Lawrence River. These projects have been great to us to develop our technology and to prove the reliability of what we are building. But as you know, we've seen in the latest months that this issue is critical. So of course, we want to be integrators of the solution and have this system that could be either deployed by us or sold to other companies that already do the deployment of renewable energy projects. So, you know, as of right now, we will remain manufacturer of batteries. We will take on the role of integrator for the pilot projects. And as we move forward, then we can reassess whether we want to continue in this direction or open up to other partners to deploy these solutions faster.
When you say battery manufacturing, so because currently I suspect that you buy the cells, so you procure different components from different established manufacturer and just assemble them. So that's the model you intend to pursue.
Exactly. Sorry, maybe if I misspoke. We are a module and pack integrator. So we buy lithium-ion and sodium-ion cells from Asia that we integrate with our own proprietary battery management system, and thermal management as well, enclosures. So that's something we already do on a daily basis for other markets. But as we are entering into the renewable energy sector, we wanted to have a complete solution that would be a plug and play for the grid.
And then you're correct, and I will leave the other question for the floor, but the inverter right now is like part of your offering, or it's something, the user, the owner, whatever, has to procure by himself?
Yeah, so we are in discussions right now with an inverter company that already has a solution for this type of projects. So it's going to be integrated inside of the system. So as one standalone unit, the part that we control is the energy storage part. So the batteries is what we control the most. The rest we will work with tier 1 suppliers for the components.
Okay, go on.
No, go ahead.
Just one last question then. What's your how your solution is different from others on the market? What's your unique value proposition?
It's always a great question. So as of right now, the area for small energy storage solutions, so in the realm of 200 kilowatts, so below 1 megawatt hour of energy is not that. There aren't that many solutions. So we are the first to provide sodium ion in that sector, especially built in Canada, which is one of our core values, to have a local supply chain for this critical project.
3 very quick numbers: cost per kilowatt hour, round trip efficiency, and ideal storage duration.
Yeah, so average outage duration is most of the outages are less than 4 hours. So that's 4 hours is the maximum length of an outage that we're striving for. So 4-hour system, if you're then the rest of the questions. So the cost per kilowatt hour is not really, we will integrate this, but we would like to provide it as a battery as a service business model. So we would, of course, have the cost as low as possible, but we ensure that the benefits to the client are there even from day one. So from the first year, you would be making money from installing this system.
Very good. Thank you very much for your presentation.
Thank you. Thank you.
Thank you.
This time passed very quickly for everyone, don't worry. Thank you very much.
Can we leave the room? All right.
Yeah.
Thank you.
Yes, you can leave the
Cheers.
room right now. We will
Before
be back. It was great.
All right. Bye-bye.
Rest of the day. Very good. Okay. And so the last one in this group, and the last one in this group also for the energy storage, AlumaPower. We are waiting for Rob right now. That just entered. Very good. Hello, hi Rob. Great to have you.
Hello, thanks for having us. Appreciate it.
Welcome and congratulations on making this to the top 60 of Free Electrons 2025. We are very happy to have you here. We are all together in the room, looking forward to get to know your solution better. And so whenever you are ready, please share your screen and you can start your presentation. We will count 6 minutes for that.
Great.
We can see
you. Yeah, great. Good afternoon. Understand you're in Montreal and I'm in the same time zone, so I can say that. I'm Rob Alexander. I'm CEO and co-founder of AlumaPower. And today I'm going to explain how aluminum becomes the clean fuel for our future. You all are aware of this need for more power, largely driven by our love of AI. And the challenge that you're faced with is how are we going to provide that power in the timeframes that we're talking about? And right now, the fastest source of that energy is wind and solar, 1 to 2 years lead time. But it comes, of course, with the issue of variability. We've got the short-term variability issue largely solved with our best systems, lithium ion phosphate. But over a day and over a season, we have a much larger problem for duration. I want you to think of aluminum. I'm holding one of our aluminum fuel discs here as solid electricity, essentially with infinite duration. This lasts forever. And what makes it compelling is it has 2.5 times the energy density of gasoline or diesel. And when you're transporting it, it uses existing infrastructure for that transportation with zero loss, unlike things like hydrogen. And we already have around the world 245 terawatt hours of production in place with ample stores of scrap aluminum. And so we see it as the solution to feed a lot of this demand, meet a lot of this demand, long duration, high power and energy density, very safe and rapidly deployable. And it provides energy security locally that's very scalable. And just with existing sources of scrap aluminum globally, would meet half of that 500 terawatt demand. Now, I'm going to talk about it a little later. We're not the only ones with the ability to use scrap aluminum as a fuel source. There's another company called Found Energy out of Boston. Together, we've created Global Aluminum Energy Alliance, and I'll talk about that at the very end of this presentation. In terms of how we did it, we're not going to be able to go into depth, but essentially, aluminum air batteries were invented in the 60s. We solved all the issues that kept them from scaling. The biggest single thing was instead of having a static fixed anode of aluminum, we spin it in the form of this fuel disc. And what that does is it creates a chemical milling effect on the surface, which then allows you to use impure aluminum, which gets the cost way, way down, also improves usability of the solution. Our first product is a containerized version of this with multiple cells in it, produces 135 kilowatts in a 20-foot container, runs for 22 hours solid, and is also very, very scalable and stackable. So depending on how much power you can stack these units on top of each other wherever they might be needed. From a cost perspective, it's very, very compelling. At ultimate scale, it'll be comparable to a natural gas turbine. Coming out of the gate will be a half of the cost of a hydrogen fuel cells. It's also very power dense because you can stack it. You get into power densities of like 40 megawatts per acre. From a levelized cost of operation, we're comparable to a diesel BESS solar system. And significantly lower for those that want 100% renewables. If they were versus just solar with a BESS system, which would be about $180, we'd be down around $123. So a substantial capital improvement, and then also very easy to locate in any location you might need. Now you don't need to have natural gas available to get to these kinds of costs. In terms of how it works in practice, the supply chain really starts with that scrap aluminum. We recast that aluminum, the form of these discs. We're delivering the discs and the sodium hydroxide, which is our electrolyte, to these containers. We're now working with a hyperscaler that we're using actually their distillate water as our water source, and we're using and producing clean electricity and heat. There's an off product here, aluminum trihydrate. It has value. Today, we launched in Toronto. Last year, we use it as a flocculant for wastewater treatment, but it has other value. It can be used for eco cements, ceramics, but also could be used to close the circle. So where we ultimately want to go is to make a fuel grade aluminum that could be done in each geographic area. In terms of our rollout plan, we launched, as I said, back in Toronto last summer. There we were charging an EV fleet for a courier company in Canada, also demonstrated powering a boat. multiple military contracts. What we're looking for right now from this group is partners that want to pilot and demonstrate with these containers in that kind of megawatt scale to start. Cost would be about 1,000 kilowatts per month of that pilot cost. For the capital costs, obviously depends on how much you use for the operating costs. And where we're going is we want to scale these into very large facilities. So we are working with hyperscaler now, and that's where we ultimately see this playing. Team-wise, I've got an experienced team and a scaling partner in Martin Rail, which is a large auto company. So looking for pilots, and I know I hit my 6 minutes, so I went a little overboard there, but open to questions and on this or on Gaia. Thanks, Martina.
Thank you very much. Exactly. Let's go to questions right now.
Hello, this is Ivan from CLP. Several questions from me. First question is, what is the key difference of your technology versus aluminum air battery? Is it the same thing?
The key difference between a traditional aluminum air battery, I'm just going to stop sharing screen here if I can, because my hands will be able to do this. A typical aluminum air battery is a static plate of aluminum with an air-breathing cathode on the other side. What we've done is we've used a disc, okay? And this disc now rotates in there, air-breathing cathode on either side, so you get double the amount of power. But that spinning disc is what allows you to get rid of the off products. There's a parasitic reaction, creates hydrogen. We basically counter the parasitic reaction with a physical movement, which in turn allows you to use impure aluminum, which is 1/8 the cost and 0 emissions in the process. There's another problem with traditional aluminum air. They have to use pure aluminum. We don't have to do that.
Okay, thank you. Another question is, like, if we consider this technology as just a backup, like data center backup or like backup digital generation purposes, would the aluminum like storage time affect the generation when it
No.
like used to generate?
No, so it's if I store this aluminum for 10 years, if I understand your question properly, it works just as well 10 years later. There's no degradation in the fuel content and the energy content. So that's a nice stable power whenever you need it.
Okay. Last question for me is like, I don't think like every market have those like value chain ready, from like aluminum supply to those like aluminum recycling. So what is your plan for that one? I guess your business model is mainly just to produce the battery itself, right? Without considering supplying aluminum like those.
No, we need to, because we're disruptive and we're new, we need to be doing both. So we're doing, obviously we're producing the galvanic generators, but we also are setting up the fuel supply chain. So we're working with one of the largest in the world, aluminum companies that can supply globally and be able to provide that, depending on which country, but they're global. There's a couple of really big ones. You can probably guess who I'm talking about, to be able to provide those fuel discs from scrap aluminum. There is a lot of scrap aluminum available around the world, so that is our fuel source, and we cast it. So if any continent I go to, everybody is already casting aluminum. That exists already in every country. Now, I don't want to do it in every country at once. I want to pick one at a time. And when we start this.
Hi, Rob. Yeah, Suchi from Origin. Just wanted to ask you if you can step through the refueling process, and then also about fuel stockpiling. How does operationally that work?
Yeah. So essentially what happens is you insert these fuel discs into that unit, and they get consumed. This fuel disc would last 22 hours full power. At the end of that, you've got a very small film that gets loaded out, and then you put in a new disc. Okay, so that's the refueling. It's very, very quick. For the hyperscaler that we're talking about, the data center, they're going to do that with an automated system, a robotic system, to actually do the refueling. At lower scale, you can do it manually. There's a fluid exchange that also is happening in there takes that off product out, that aluminum trihydrate. So you start with the sodium hydroxide fluid system, and then you take the off product out, and eventually you fill up the tank, and they pull that away to be recycled. Does that help?
Thank you. Very good, and we are right on time. There are more questions in the room, but we will get them to you in a written form because we want to make sure that all the doubts are clarified. Rob, thank you very much for your presentation. Also, Bremner, it's great to have you here. We see you right now, and that's it.
Thank you very much. Appreciate the time.
Thank you.
Thank you.
Yes, yes, it was a pleasure, and we will be in touch. Have a good rest of the day.
You too.
Thank you. Exactly.
This will be it again. Let's go.
Okay, and we are ready for Eolic Wall. Alfredo will join us. And we are going to have to start asking next generation renewables. Hello, I'm Alfredo. Good afternoon. Hi, Natalia. It's great to welcome to the pitch room and congratulations on being in the top 60 of free electrons 2025. We are here more than 30, all 7 utilities present, many people online ready for your presentation. So you can start sharing your screen and we will be counting 6 minutes for your presentation.
All right, I'm starting to share my presentation. Can you confirm if you can see my screen? I can hear.
Yes,
I see it.
Okay. So, okay, let's start. My name is Alfredo. I'm from Eolic Wall. I'm sure you've seen solar energy everywhere. That's not the case for wind energy. In fact, 40% of all solar installed capacity in the world comes from distributed generation. However, for wind energy, that number falls to 1%, meaning there's an enormous absence of wind energy in the distributed generation market. And that is because mainly for wind turbines to be efficient, they must be gigantic. That is, small wind turbines are not efficient at all. And that's precisely what we are solving in the Eolic Wall. We have created a whole new wind energy system capable of reaching the same efficiency and LCOE levels with those gigantic wind turbines, but at a fraction of the size. And to do this, we have developed this technology following 2 pillars. The first one, modularity. We have designed these Eolic cells to be modular, so we can stack them like Lego to build larger structures capable of feeding almost every single energy need with a unique solution. And by having a unique solution and being modular, we can master the use of these devices to take advantage of economies of scale. If you think about why solar energy is so successful in distributed generation, that's partly because they have a modular solution, and that's the way it must be for wind energy as well. The second pillar is lower LCOE. To achieve this, we have designed this Eolic cell to do many things at a time. The first thing is that it increases wind speed. By increasing wind speed, we can harness more power from the same wind resources, which is efficiency. But it's not only that. We have designed this technology to work with a magnetic levitation rotor that allows us to minimize friction and increase efficiency even further. Also, this magnetic levitation rotor allows us to reduce all moving parts, which have a positive impact on low maintenance and extended lifespan. Also, we have worked with Oak Ridge National Laboratory from the United States. And what we did with them was to co-create something we call the arc flux generator. This is a new generation system specifically designed for the Eolic cell. And what this new generation system allows us to eliminate all mechanical parts, mechanical components, meaning we won't need any drivetrain system. There is no need for a gearbox. All those mechanical components just disappear from this equation. So we are just simplifying the overall design and maximizing that power curve, which allow us to achieve a higher capacity factor. If you compare our technology with a conventional and small wind, you'll find that in terms of efficiency, capacity factor, maintenance, lifetime, we beat them. Our LCOE is 6 times lower than any conventional small wind. And if you compare our LCOE with any other technology like solar or wind onshore or wind offshore, you'll find that we have in the similar levels of those technologies as well. In relation to IP, we have a patent portfolio with patents granted in the United States, Europe, India, China, Korea, Japan, and many other countries. Regarding the total addressable opportunity, recently, the National Renewable Laboratory from the United States made a study, and they found that only in the United States, the market opportunity is as high as $2 trillion. And globally, we are talking about a market opportunity over $8 trillion. That is, we are talking about a massive global market. Our proposed business model relates to energy as a service, where there's going to be a initial pay down to cover the cost, and then the profit will come from the energy generated. Our value proposition goes through decarbonization, but it's not just pure decarbonization. It's a decarbonization with no green premium, which is very, very important. We have several pilot agreements. For instance, there is a residential developer. They want to use this technology to decarbonize their buildings. There is an energy company that wants to integrate this technology in their product portfolio to offer wind solutions to their clients. There is also a textile company. They want to decarbonize their industrial facilities and also their cotton fields. And like them, there are many other companies that want to adopt this technology in the mining sector, in the energy sector as well. Regarding the pilot plant, we are using as an example EDP. EDP has a clear focus on decarbonization, but also on decentralization. We would like to help them to offer a complete distributed energy solution. Today, they offer solar and storage to the client. With us, they can also offer cost-effective wind solution to their product to their client portfolio. Regarding the specs for a pilot, key point to mention here is that all units will be connected to the cloud for monitoring and operation, and all units will have plug-and-play power electronics for easy installation as well. Our goal is to build a partnership to disrupt the distributed generation market and make wind energy as accessible and scalable as solar energy is today in the distributed generation market. Let's talk. Happy to connect and to answer all your questions. This is Eolic Wall, the next generation of wind energy systems.
Perfect timing. Let's then move to questions.
Hi, Alfredo. Maxime Godin from Hydro-Québec. Thank you for presentation. What is the operating voltage and the average performance of the power output of the Eolic Wall?
The power output, the nominal power output is going to be between 2 and 5 kilowatts power. That's going to be the first unit, and the voltage we so far have achieved is about 120 volts for the unit.
Does it come with its own inverter, or you need to provide your own one?
There's the power electronics behind all this technology is very similar to any solar installation. Indeed, the only thing that differs from any solar installation is that solar is AC current. This is going to be a DC current. In the case of this technology, it's going to be AC current. Besides that differentiation, everything else in power electronics is going to be the same. The converter, controller, maybe battery bank, but it's going to be basically the same stuff, which is good because it will allow us to make in cases when we want to maybe do a hybrid system, it will allow us to make a smooth integration between those two renewable energies.
Okay. Have no tests been performed on the wind turbine and twin tunnel? Like, is there noise produced?
There is a small noise which is related to a calibration we have to do it with the magnetic levitation rotor. But I mean, there is almost, it's almost noiseless, I have to say, which makes this technology very ideal, and that's why we also feel comfortable saying that there are a few moving parts in this technology, as well as contactless components, which allow us to make an almost noiseless technology.
Can it operate in a snow-covered environment, or is there protection in case of snow blockage?
You mentioned snow?
Yeah, snow. I'm from a snowy country.
Oh. Yeah. Good question. We haven't tested this technology in a snow environment, but what we expected is that shouldn't be any problem. Why? Because usually two things come here into place. For instance, all the magnetic levitation system works properly when there is a cold weather, but also because there is a contactless component, we shouldn't expect we should. It's a contactless all the components, meaning the magnetic levitation rotor in the generation system, are encased. It's not that they out of exposed to the environment. They are enclosed by this kind of a box, this Eolic cell. So all these magnetic levitation rotor in generation system are just protected from the environment. So they won't be exposed to snow.
All right. Just one small question. Do the stacks have to be mounted on a rotating platform to follow the direction of the wind, or do they rotate already in and by themselves?
Yeah, that's true. There is a pivot, and let me show you. For instance, this is one of the prototypes. If you see in the base, there is a kind of a pivot, and that pivot is which allow us to make this prototype face the wind direction. So yes, these devices will face wind direction with a base that will let them pivot accordingly, and won't need any active assistance. I have to say, it's only going to be passive assistance. So they just face wind direction without any external energy.
Okay, thank you.
Very good. I think there are some more questions in the room, but the time is up, so we will make sure that more questions will get to you in a written form. Alfredo, thank you very much for being here and also out of this room. Thank you. Very good. Let's keep up with our schedule. We are waiting right now for Airloom Energy and Neil to present. Hello, hi Neil. Great to have you. Welcome.
Thank you.
And congratulations on being in the top 60. It's great to have you with us. We are ready for your presentation. There are all 7 utilities in the room.
Okay.
And please share your screen. You can start your presentation. We will count 6 minutes for that.
Okay, very good. Can you see my screen now?
Yes, perfectly.
Okay. Well, hello everyone. My name is Neil Rickner. I'm the CEO of Airloom Energy. Thank you so much for the opportunity today. I'm presenting Airloom Energy. I'll start with the problem we're trying to solve is that wind energy that is made by horizontal axis wind, which is the three-bladed wind turbine that you all know and familiar with, is not coming down in cost anymore. And if we want wind energy to be available and ubiquitous, we need to find a new way to make energy from the wind. And that's us. My background, I started my career as an F-18 pilot in the US Marines. My CTO made satellites for Boeing for about a decade and then has been making unmanned aerial systems. My chief product officer was the CTO of Boom Supersonic. So we're a super talented team. Some of our teammates have built wind turbines and also roller coasters, which actually really applies in this scenario. We're backed by Breakthrough Energy Ventures, Crosscut, Lower Carbon Capital, and we've also gotten some government contracts from the United States Air Force, along with the state of Wyoming. Our solution is low-cost wind energy that can be mass manufactured, that is automated manufacturing, built with steel and aluminum, so common materials, shipped in standard transportation networks like containers and put up with forklifts and not cranes. This means we're doing wind by industrial methods instead of heavy industrial methods, which is what's used today. If you see the blade or the sail on the rail, as it's pictured here, the wind hits that wing and it's propelled forward. And the wings in unison pull on a belt around the track, and those belts are then passed through electric generation. Right now it's induction motors. So very low cost, sort of off-the-shelf materials and off-the-shelf hardware for the most part. We design the wings and the rails especially, but basically everything else is very common, easy to ship, easy to install, and easy to maintain. The reason this can be so low cost is because we start with better physics. We get closer to the Betz limit, which is the theoretical limit for how much energy you can pull from the wind. We do it with very, very low cost swept area. So each incremental blade is just a little bit more track and a little bit more wing. So we can make very, very large systems, think 20 megawatts at a time. I mentioned that we're making things at mass production. So we're going to be very, very low cost materials. So our CapEx is going to be very low. But in addition to that, our balance of plant costs, just given the site layouts, are going to be very low. So less electrical collection, fewer roads. It's a system that allows for the optimization of a site. And you can also use the land for other things like farming and ranching underneath it. And then finally, the transportation is very simple. And what that does is open up additional siting opportunities that aren't available for big wind turbines today. So not only is Heirloom going to be lower costs, but you can also put Heirloom in places where there are height restrictions, in places that are hard to reach, like remote areas, mines, islands, and then also anywhere you can't get a big crane. Think many parts of the global south, you can't put up a big wind turbine, but you can install an Heirloom turbine. If you're familiar with wind turbine power curves, you'll see that ours looks very similar. And except that we move a little bit to the left. We produce energy at lower wind speeds, and we get to rated power much more quickly. You're also seeing capacity factors in many of our deployment locations of north of 50%, so 50-55% capacity factors. All of this combines to be a very, very low cost of energy. You see the gray line, which is what we're predicting is the horizontal axis wind cost of energy. And if we can get to $10 a megawatt hour, I think you'll agree that we'll have a big, big market. Right now, that market is about 200 billion annually. We're looking at 100 million in revenue just in 2030. Our pilot projects, we're building one that's very similar to this now in Wyoming, but we're looking for partners, and that's really why I'm excited to speak with you today. We see Heirloom as best paired with other generation sources. So in this picture, it's paired with solar, but it could be geothermal or gas. And our first projects we think would be best to power things like data centers. We're also building a plan to put to be a part of a microgrid on a military base. So we could be deployed behind the meter in these early projects. Also very happy to explore opportunities with you to build a front of the meter pilot project that because we know just how hard it is to bring a generation source unique like Heirloom into a grid scenario. So my last slide, what I'm presenting here is a pathway for partnership. I like to say, my previous experience, I spent about 10 years at Google and Google X bringing a new wind technology to market. And what I learned from that experience is that in this industry, I have to have experienced partners. So in that company, I partnered with Shell. We did about a $50 million deal with Shell and Alphabet to spin out a company from Google X. And that's what I'm looking to do again here today is find a partner that has industrial experience in the energy industry and build a path forward for Heirloom to enter the market. Thank you very much.
Very good, Neil. Thank you very much. And let's move right away to questions.
Hi, Neil. Suchi from Origin here. Thank you very much for the presentation and congratulations on making it through to the top 60 for Electrons this year. Really interesting tech that you guys have developed. And I guess one of the first questions that we had is just around footprint and whether you can give us a comparison compared to conventional wind in terms of how many megawatts per square hectare, square acre, whatever unit.
Yeah, it's a great question, and intuitively you think it'd be more, but believe it or not, we'd need more land, but actually it's about the same. We're about 10 megawatts per square kilometer, and the reason for that is that we're much more efficient in our capture of wind energy, which is I can talk with my hands, but you know, a wind turbine today, the way the sites are laid out, you let a lot of wind go by, and you also have to have big offsets. We cover a full frontage of a wind direction. And then also we don't have the big offsets. We only have a 10-meter blade. So our offset for wake turbulence recovery is about 50 or 60 meters. So we pack a lot of heirlooms into a small space. And as I said before, you can farm and ranch underneath. You could also imagine, you have to sort of reimagine what the layout looks like. We can go across the top of roads, think of us like a bridge in that way. And then in some scenarios, we'll be deployed not necessarily in a straight line. So what we're presenting here is symmetric, but it doesn't always have to be.
Okay. And in terms of that I guess the connection and the way that they're strung in the lines, is there any limitation in that kind of parallel connection that if one turbine doesn't operate, then the entire string is not operational? Or can you talk us through some of that redundancy?
Yeah, that's a great question as well. No, so one of my engineers actually has been building roller coasters for the last 25 years for Disney and Universal. And what we've got is a very similar setup to what you see in a roller coaster. In fact, we copied it from a roller coaster, which is essentially you end up with one of the like a wing that is not operating functionally will just be pulled off the track into a penalty box, I like to call it. So you won't lose the whole system if just one wing goes down.
Okay, and then conventional string inverter or something at the end of a line? Or is there any special requirement for the power conversion?
No special requirement. Our electrical engineer has been building horizontal axis wind farms for 30 years. What we've got now essentially is what you would interact with as a pad mount transformer, similar to what you're used to today.
Yeah. How about noise? Does it produce any noise? Because roller coasters are very noisy. People screaming.
It's a totally fair question. I think intuitively you think they're going to be noisy, but when you were experiencing that noise from the roller coaster, you were probably standing right next to it. It is true that we're going to have some standoff. What we have said, what we've measured so far is that at a kilometer, you're going to have less than a 20 decibel sound, which is sort of like rustling papers. So you basically won't hear it outside of about a kilometer or a little bit more. It doesn't have that low frequency noise. It does sound like a roller coaster though. You're absolutely right.
Okay.
But anyway, I'm just making the point that it dissipates very quickly over a small distance.
We have one question online, yes?
Hi, dear. This is Edgecom from JERA. I just would like to ask, do these units generate wake effects? The reason I'm asking this is because I noticed you install these units just beside each other. Doesn't that affect their performance?
Yes, they absolutely create a wake effect, but that wake effect is, and we put that through a full CFD, and I will say, because I don't have much time here, I will just say, yes, we've modeled that, and we have done the offsets to allow for the wind to fully recover. So you're absolutely right. In any wind generation device, there is a wake effect. We're just setting the front rail and the back rail far enough so that the wind can recover fully before it goes to the next rail and then to the next system.
Very good. I will wrap up here, although we have a question from JERA team, one more in a written form, but we will pass it to you in that form as well. Neil, thank you very much for your presentation.
Thank you, everybody.
Yes, it was great to have you. Have a good rest of the day, and we will be in touch, of course.
Okay, very good. Thank you.
Good. For everyone online, we are trying to rush those questions written online to be shared here, but don't worry, all the questions are captured. We will pass them to startups, okay? So worry not. Okay, right now we are moving to startup number 31. So we are starting the second half. Prezerv, and we are waiting for Pam. Oh, he's here. Very good. Pam, welcome. Great to have you. Welcome to the pitch room, and also congratulations on making this to the top 60 of Free Electrons 2025. We are all here to meet your solution. So whenever you are ready, share your screen, and we will count 6 minutes for your presentation.
Sounds good. Great to meet everyone. Hi, everyone. We are Prezerv, and we are creating the 3D Google map of the underground. Over the past 2 decades, tech companies have done a great job mapping our streets, but not much has been done to map what's underground, our utilities, water, internet, gas, electricity infrastructure. At Prezerv, we are focused on developing AI-powered underground mapping technologies to accelerate energy projects. As most of you probably are aware, construction projects run late and finish over the budget. And one of the root causes of that issue is that contractors don't know where underground utilities are. And this particular issue, the inaccurate underground map issue, causes more than 500,000 accidents in the US alone. That's more than once per minute. And it's a global problem. So you might ask what contractors are using for maps today. Most use inaccurate, outdated historical records. In addition, the historical records are mostly two-dimensional. They lack the critical depth information. So contractors being in the dark, they often end up digging some random holes, looking for pipes. And this whole process is slow, expensive, and for the most part, ineffective. So based on our customer interviews, extensive customer interviews, we realized that customers want to have on-time project delivery. And at Prezerv, we are focused on creating automated 3D digital twin of the underground to help them meet that need. How do we do it? We use data from 3D radar scanners. This is a picture of the unit that we use in our operation. These scanners have been developed by US military in 1960s, but, oops, sorry. But the signals coming out of these scanners are complex electromagnetic signals. And these scanners scan the ground at 300 different frequencies, makes the analysis even more complex. And 1 hour operation of this scanner creates about 5 billion images. You could run it at 70 miles per hour, but we simply don't have enough people to efficiently interpret the signals and convert it into the 3D model of the underground in a timely manner. And that is why in the past 3 years, we spent a lot of time and effort to develop an AI solution that goes through the signals and interpret them to create a 3D digital twin of the underground in near real time and more accurately than any technicians can do. This slide compares the accuracy and speed of our solution against the other conventional method that is being used today. So our solution can map the underground 100 times faster with inch accuracy. And there is no other solution in the marketplace that can match our speed and accuracy. We have been piloting the technology over the past few months. Currently, we have contract with a major utility in Midwest in the US, and we also have performed a number of paid pilots with utilities across the US, and we are continuing to do that. We have a very easy three-step process. First, you would plan a project. You could select your project on a map. Once we have the area, we have it scanned with a 3D scanner. And after that, we would upload the files to the cloud and interpret it, create a 3D model of the underground. This is from one of the substation projects that we did last year in Massachusetts, in the US, close to Boston area. And as you see here, for this project, because we were working in a 100-year-old substation, there wasn't a whole lot of data, underground data available. So we walked the scanner around the site, and within 1 hour, we were able to create a map that was used by contractor to machine excavate the site, and they did not have a single accident. This is another project that we did outside Boston. On the top image, you see the ground elevation profile. Once you get closer to the surface, you start seeing the underground utility line, and this is a snapshot of the model from underground. So this model is in point cloud. You could do a spatial analysis measurements, obtain the depths, and also true elevation of the pipes. We have a SaaS business model, and we sell to utilities, municipalities, and energy companies around the world. And I would love to work with you on a pilot. We also have an open seed round. So if you are interested in investing in Prezerv, by all means, I would welcome that discussion. Now that I talked about what we do, let's talk about the team. I have 12 years of experience in construction of energy projects. Our chief scientist, Yuri, has 35 years of experience in developing automated geospatial applications for defense and aerospace industries. And we also are fortunate to have an outstanding team of advisors, both in business and academia. Thank you for your time. I welcome any questions you have.
Exactly. Thank you very much. And we can move to questions right away.
Yeah, I can start with a few questions. Thank you, Kev, for the presentation. It's Andre here from EDP. Maybe starting with the technology itself. So 2 questions. One is, are you able to detect different types of cabling or pipes, meaning water pipes, electrical cabling, fiber, gas? So in your underground mapping, are you able to differentiate those? And is there a difference in your accuracy in different materials that you have to scan? So a road versus any other type of soil. So is there a difference in the accuracy?
Sure. Yeah, great questions. In terms of the accuracy in different soil environments. So the way we are analyzing, and that's part of our secret sauce. We are analyzing the data, the signals in a sense to take out the local soils effect. So we're not depending on that. The only limitation is that we do not see below the groundwater table. So if there is water, that's where our analysis stops. But above that, we've tested the technology in different soil conditions, and we can help you with that. About your first question about basically that is materials characterization. Right now, we could differentiate between power lines. We know how the signal for fiber optics line would look like. PVC, steel pipes. We haven't automated that part yet, but manually we are providing that if needed.
And then the output of your solution is just the mapping, or then when you talk about the automated conversion to some level of information, what type of insights, if you can, what type of insights do you provide? Or is it just the mapping itself?
Sure. So it's a 3D mapping. It's a 3D model. So that means that you get depths and true elevation of pipes. And we also provide, in addition to where the pipes are, we provide the size of the pipes. We are also looking at additional analytics, such as leak detections. And also we could see cavities underground other type of structures, buried structures. But yeah, I think for this program, I submitted I discussed only the 3D mapping of the underground utilities pipelines.
So one question before handing over here to Ion is about your business model. So do you survey the places yourself, or do the utilities do that by themselves, and then, or you have a contractor, and then do we pay per map in your subscription, or how does the subscription work?
Sure. So right now during the pilot phase, we charge per square feet of the area we map. And we basically, we have a scanner, we would mobilize to the site, scan the site for customers to evaluate the map. And then once we get into the commercial contract, then at that time we would probably partner with a local scanning company or ask the utilities to purchase their own scanners. The scanner is off the shelf and anyone can buy it. And then we would basically just interpret the signals for you. If you want more, if you want it to be basically more like a stamp survey, then we would work with another partner, a surveyor partner, to provide you with that report.
Thank you very much. We are right on time, although questions are still here, not only in the room, but also in the chat. Tammy will receive all of them in a written form, so don't worry, we want to as well clarify any doubts. Thank you very much.
Thank you. Bye for now.
Very good. Thank you very much. Have a good rest of the
Thanks.
day.
Bye.
Bye-bye. Good. All right, let's go to now you can click the bottom right button. It's to leave the room. Done. And now start up Rhizome, and we are waiting for Michelle. Hello, hi Michelle. Great to have you. Welcome. I see you already ready for the presentation. I want to just welcome you and say that we are very happy to have you. Congratulations on making this with the top 16. The room is full of curious minds to learn more about your solution. So go ahead. We will count 6 minutes for your presentation.
Yeah, thank you very much. And first of all, thank you for the opportunity for being here. I'm very excited about this. My name is Mish Sadani. I'm the co-founder and CEO of Rhizome, where we've built an AI platform for grid resilience planning. And I'd like to start by highlighting the climate adaptation challenge that we have in the utility sector. And that is really over the last decade, extreme weather events globally have been increasing in frequency and intensity. And in the US, what that's meant is that extreme weather-related power outages have increased by almost 4 times in that span, whereas over the same period, reliability metrics have remained largely flat. Now, ICF describes this as a $500 billion resilience investment gap problem. It's the amount of capital that's required to really limit those increases in losses that we actually experience in the US. And meanwhile, credit ratings agencies have been downgrading utilities at the same time, primarily due to climate risks and liquidity challenges. So our fundamental thesis is to help guide utilities into prioritizing investments to target the most amount of risk with the fewest amount of dollars. And utilities, transmission and distribution utilities globally have been really investing in the hardening of the system. They've been rebuilding overhead lines. They've been undergrounding those lines. They've been deploying reclosers, replacing aging assets, really to try to mitigate those risks and provide better service to customers. But what we typically see are a couple of challenges when it comes to the planning of those investments. There's really incomplete visibility into asset risk and how outages actually occur. And then quantifying cost-benefit analyses that incorporate the resilience value of those investments. And then there's also a lack of tools that cause engineers and planners a whole lot of time digging into spreadsheets to identify what are the data sets that we need to pull in to actually figure out which investments to make in the right location. So what we've done at Rhizome, we've built an AI-powered software suite, And we have three major tools that really help a utility assess vulnerabilities on the system, optimize investments, and then ultimately justify those investments in front of their regulators. Grid Adapt is our reliability and resilience planning platform that helps understand extreme weather vulnerability and helps understand the reduction of risk from investments. That leads into GridFirm, where if you can understand an asset's vulnerability, and you can understand what's the potential for a utility asset to cause a fire. And if you're deploying hardening investments, how do you quantify the reduction in risk from the ignition potential of that asset failure? And then lastly is Grid Kava, which is a climate and vulnerability assessment that we've digitized mostly for smaller utilities, municipal utilities and cooperative utilities, just to give them a sense of where the vulnerabilities might exist on their system. We've been deploying in our short time of 2 years in the space with some of the leading utilities in the US, already starting to provide value in terms of assisting their engineering teams, prioritizing investments, and already getting some justification in terms of regulatory filings in front of regulators. Behind the scenes, we've built an AI-powered platform called Aspen. What this platform does is it ingests data from the utility system, the asset data, including the location, types of assets. We look at the historical record of outages that you've had on your system. We look at the maintenance records and the capital investments that have been made in history as well. So the first thing our platform does is learn signals from history. What are the conditions that have led to risk and failures on the system? We then take climate data from community Earth system models, downscaled specifically to your geography, to understand how those drivers of outages in terms of the storms, extreme temperature events, wind events, ice events, going to change over time, and how is that going to lead to changes in outages that you'd experience in the future. So from that baseline risk model, then we can understand the mitigation of investments. So we look at pole upgrades, vegetation management, undergrounding, and a couple of dozen different investments, and understand how much is that reducing the risk profile on a given protected section or on a circuit. And we can quantify those benefits for wildfire risk, reliability, resilience, and reduce O&M as well. Now, when we've applied this modeling framework with one of our core customers, CenterPoint Energy in Houston, where they experience hurricanes at increasing frequency and intensity, it was to support their $5 billion resilience plan that they just filed to their Texas regulators. When we deployed the model and the application, we found that we were able to help them reduce 20% in their time in planning investments and coming up with benefit metrics. Our projection models and our forecast for outages outpaced their existing models, getting to 90% accuracy for the frequency of outages forecasted on a year-over-year basis. And then lastly is through reprioritization of many of their investments, we identified an additional capture of 21% of outage reduction based off of just reprioritizing those investments through more smarter, more forward-looking models. So for the pilot project for free electrons, we're proposing a 4 to 6 month pilot. What we'll do is we'll ingest asset and GIS data. We'll look at, say, 10 years of outage data. A little bit more is a little bit better. We'll also pull weather and climate data that we have readily available on our platform to go through that risk model to project outages on a protected section by protection section basis and quantify investment benefits of 3 different investments. We'll look at this on 10 feeders on your system. And ultimately, the goal is to get to the bottom right, where you identify the cost for an investment going into a protected section, and you can identify the dollars per customer minutes interrupted reduced from that investment that's driven by forward-looking empirical models. So our team is comprised of climate scientists, utility subject matter experts, and machine learning engineers whose singular sole purpose is to build models that help utilities adapt to climate change. And lastly, we've interfaced with various free electrons utilities and know that climate adaptation is very high on the list in terms of priority. With EDP articulating that in terms of a major strategy priority, ESB experiencing major storm damage and needing to reduce the damage and restoration time. E.ON, who is anticipating regulatory actions that we could assist with. CLP, who's built a maintenance model for resilience that we can incorporate into a planning model. And then for Hydro-Quebec, which is experiencing very cold weather and frequent storms that they need to adapt to. And I'll leave it at that and leave room for questions. Thank you very much.
Perfect. Thank you very much. Let's move right away to questions.
Okay.
Hello, Chair. Thanks for the presentation and congrats for the you made it to the top 60. So I'm Mochi from Jetter. So on behalf of other USDD, let me ask a couple of questions. So the first question is, I understand the extreme weather and event is increasing, and what is the time scale of the prediction in your model?
Yeah, that's a very good question. So climate models go out to 2100. So when we're trying to understand how extreme weather events are changing and making that specific to a geography for many hazards, as I said, extreme temperature, winds, storms, as well as precipitation, then those extreme weather metrics go out to 2100, and we can provide validation metrics for those as well. From a planning perspective, we model risk going out to 2070. So if you're looking to make infrastructure investments that last, say, 40, 50 years anticipated, then we can capture the benefits over that forward-looking risk curve going out to 2070 to 2080, if that's helpful.
Thanks. So the prediction, the accuracy is quite key, and I understand in your POC, you are looking for the 10-year historical data. So could you tell me a little bit more? How do you collect the data, the past as well as the latest climate research?
Yeah, good question. So first, when we look at climatology, we look at 40 years history of weather patterns and what climatology is saying. And that's what we use for the basis of projecting how extreme weather events may change in the future. When we look at the 10 years of historical outage data, we're looking to understand what's the relationship between extreme weather and failures on the system. And so when we build the model, our models are learning from those various relationships at high resolutions. And then as the extreme events change, we're able to anticipate with a fairly high degree of confidence how the outages are likely going to change. Now, of course, this is all within a band of confidence, but the purpose is to get to cost-benefit metrics that help stand the regulatory scrutiny, which we align with very well.
For me, last question. So, yeah, I understand you're looking for the opportunity to have the pilot with distribution system. However, do you think this solution can be used for the other purposes, such as development planning for renewable energy, wind, or solar?
That's a great question. So it definitely can be very useful for planning new generation. Now, we haven't built those models yet, but when we construct a climate model for a specific region, we can absolutely apply those models to potential generation sites for primarily wind and solar. So that when you're trying to understand future patterns of wind gusts or average wind speeds on a go-forward basis, then you can understand the long-term generation profile of a generation asset. And again, we haven't built those models yet. Our focus is on transmission and distribution, but we'd be excited to actually work with someone on that.
Thanks.
Very good. Well, we have 4 seconds, but I think I will use it too. Thank you for the presentation. It was great to learn more about your solution, and congratulations.
Thank you very much. I appreciate the invitation and look forward to continuing the conversation.
Right. Thank you very much. Have a good rest of the day. We will be in touch. Thank you. You can right now as well click the bottom right to leave the room. Thank you. Okay, very good. We are done, almost. More. But right now we have as always our 12 minutes to go to the board, talk to your We are waiting right now for Connect X. No, it's not. Joining us. Oh.
Hi, everyone.
We cannot hear you, Martina. Not sure why.
Can you hear me? Hello, hello. I think right now you should. I see the green frame. Okay, anyway, hello, great to have you. Welcome to the feature, and also congratulations on making this to the top 60. We are ready to presentation. Start sharing your screen and start your presentation. We will count 6 minutes for that.
Sure. Please let me know if the screen is visible.
Yes, we can see it well and also hear you very well.
Okay. I'll jump straight in. Thank you, everyone. First of all, extremely honored to be in the top 60, very privileged among the others. We'll jump straight into it. At ConnectX, our core vision is to democratize access to affordable, cleaner, but also more reliable electricity through an AI operating system. Originally started as an enterprise system for the utility, we switched our focus back onto the built environment, which is primarily the commercial real estate, multi-unit residential buildings, and everything in between them and the industrial properties, in an effort to decarbonize them and also transform them into grid assets, not only to help the utilities and the grid to benefit from the grid savings and the power savings, but also for the buildings to generate revenues for them. So we launched a product earlier called Connected Building. We transformed the existing buildings into grid connected, grid interactive assets, revenue generating assets. And in multiple value stacks, we had helped them drop their power demand by about 60 to 85%, increase their energy efficiency, and reduce their GHG footprint, which they can monetize. But also in the effect, the third order impact of that is they can increase the value of the property. We then connect all these buildings into a VPP network, and that creates a massive impact for the utilities in concern. For example, we are currently doing a pilot in Quebec using the Hydro-Quebec GDP program, which allows for our system to be to receive incentives on an ongoing basis if we are able to reduce the power demand in response to the demand response events that's potentially going to come up in every winter. We are also working in Ontario, where we are working directly with ISO under a program and also participating in the open auction program for the capacity services. So the demand response and the capacity services are the two things that we provide, aggregating all the buildings and even also individually for all these buildings to the utilities. Here's a case in point. I mean, a typical building could generate between 20 to 25% of energy efficiency savings. They can also generate income from the grid or the market, and they can also monetize their greenhouse gas emissions. Just because we are helping them save the peak demand, that creates a lot of GHG emission reductions. This is a portfolio of 17 buildings in Quebec. This is how exactly the system works. We use BESS, battery energy systems, that's managed by our centralized control OS, which is the cloud system, and then the grid edge device, which is our energy optimization control OD. in 3 easy steps, we connect, optimize, and operate, and then aggregate all the buildings. So we are essentially a building VPP aggregator. We intend to expand that to create over $720 billion of annual value just in North America alone, and over 13.5 trillion of assets. So here are our current tractions. I mean, our customers are not utilities. Utilities are partners. We use their programs and market incentives to create value for the buildings and also for the utilities back. So here is our proposal. We propose that a utility that would choose to work with us or probably allow us to do a pilot with them either has or help us create an incentive program for them, which allows for either a CapEx subsidy for the systems that we install, and also an ongoing performance-based incentives. That typically is in kilowatt. Every peak seasons, we can help them reduce their demand. And in a collective manner, we can reduce, at a pilot level, we can reduce between 5 to 10 megawatts. So we propose that's to be instituted as a pilot program. This could last between 16 to 18 months and help us prove the point. At the beginning, of course, we would hope that the utility has an incentive program to fully finance this system, but on an ongoing basis, when it's a commercial setup, we can fully finance all of it because of our private equity partnership. So we aim to, in Quebec alone, we are looking to target over 3 gigawatt and same amount in Ontario, and we are looking to do the same in other jurisdictions in Europe and in Asia. So we could do between 1 gigawatt to 3 gigawatt, fully financed by our private equities. We intend to sign 10 to 14-year contract with underlying buildings, which continue to receive these incentives from the utilities or the market, and therefore we can create the ongoing value, and therefore we can create a massive network effect so that the utilities can defer billions of dollars of investment in fixing the grid, and we help them create what we call an Internet of Energy by enabling a distributed energy systems. And in the process, our system is fully OEM agnostic, meaning that we are able to collect and connect any number and any type of DRs. So the utilities can choose to aggregate a large number of BESS, solar, EV charging systems, heat pumps, and therefore also enable massive electrification within their jurisdictions. And these buildings will ultimately turn into connected buildings, which will be high performance net zero buildings. So that's our proposal to you. We are open to any questions you may have for us. Thanks for listening to us.
Very good. Thank you. Let's move right now to Q&A session.
So thank you, Pratik, for this presentation, and congratulations for making it to top 60. So Sylvain from Hydro-Quebec. How do you plan, if you could explain to us how you plan to enter the existing buildings market? So the ones that, for instance, that have a closed BMS, for instance, Johnson Controls, Delta, Rigolvar, Distech. So what's your strategy?
Yeah, I think that's a great question, and thank you for that question. And literally 50% of the buildings we target already have an existing BMS or a BS, building automation system. So this building automation system or BMS is typically internal looking. They're looking at energy efficiency. We go to them and we say our connected building system can seamlessly sit on the existing building automation system or BMS and provide the dynamic control based on our AI and machine learning interacting with the grid, so that those BMS then can implement those controls to bring down the power usages. So a typical example is, other than using the battery to completely discharge during the demand response events or demand response period in case of Ontario, we are also able to kind of direct the BMS or BAS to preheat or pre-cool the buildings, or also systematically or dynamically cut off some of the power supplies to non-essential usage. For example, common area light is usage when no one is using. So that's nearly 50% of all the buildings that we are currently working on, and primarily these are the office buildings. There is a case and example, which is where we are looking at a office tower in Montreal, downtown Montreal, which uses pretty much like 750 kilowatt. And we are looking at exact same scenario you just explained to us. Our system is able to connect with such BMS and BAS through the BACnet or Modbus so that we are able to implement the control in real time. If that explains your questions.
Yeah, and similarly, how do you plan or your strategy to enter the new buildings market?
Yeah, that's a great question. So our primary focus has been a lot of retrofit because we have a great profile of the building's energy efficient systems, but we have also been approached for new buildings, and new buildings approaches are implementing connected buildings from the get-go. So we are able to, using our market knowledge and our energy system knowledge, because we are energy scientists and building scientists with over 100 years of experience collectively, we have proposed them to structure the building. We don't look at the building envelope, but anything that is energy related. We're able to create a connected building right from the start, allowing them probably only to benefit from the income that they could generate by having a battery in place. But also over the period of time, we can help them stop the leakages. So right from the get-go, these buildings become connected buildings. For the retrofit, we have a lot more opportunity to create value because we just have a lot more understanding of the energy profile from the start. So if I can give you a bit of an idea, so our current market GTM is about 80-20 divided between the retrofit, because there's just so much to do in the retrofit buildings, but also 20% we are looking at the new buildings and new communities, if that makes sense.
Maybe one last question before I leave the room to my other colleagues here. What is your unique value proposition? What sets you apart from from competition in this field?
Sure. Yeah, we are unlike our traditional BMS and BS competitors, and also the VPPs. We are fully OEM agnostic, meaning that we can connect to any and all type of DERs in almost 1/10 of the time compared to a traditional BPP setup. But our understanding of building energy and the energy science and connected that to the VPP operations sets us apart. So the platform is set up to become a fundamental operating system for future smart grid, meaning that its two-tier architecture is set up such a way that it can also operate when there is no power or the network is kind of gone in an islandic manner, almost mimicking a microgrid. So this is the first, probably the platform which is fully OEM agnostic and can operate in an islandic situation in real time.
Okay, right on time. Pratik, thank you very much for your presentation. That's everything. The 10 minutes just passed.
Sure. Thank you very much. Thanks for listening.
Thank you, everyone.
Thanks, Paddy.
Thank you so much for being here with us for this presentation. Good. Have a good rest of the day. You for sure will be in touch and already gone. Vinyuta, was great to have you. Thank you.
Thank you so much.
You can click the button on the
Okay. Yeah. I was hoping they will bring me back. Yeah, sorry for that.
Okay, very good. Let's go right now to Edgecom Energy. We are going to have Begda with us. Take it right now. Hello, I see the bigger team from Edgecom. Great to have you. Hello, hi Tanner, hi Begda.
Hi, how you guys doing?
Very good. It's great to have you. Welcome to the pitch room. We are all eager to get to know your solution better in a minute, but I want to also say congratulations on making this to the top 60 of Free Electrons 2025. We are ready, so whenever you are, please share your screen. You can start your presentation and we will count 6 minutes for that.
Okay, is that showing up okay?
Yes, we can see it well and hear you as well.
Okay, fantastic. So, good afternoon, everyone. I think everyone's calling in from the Eastern time zone, so hopefully it's not too late. I'm Tanner Barrand, work for a company called Edgecom Energy. So again, you guys have all reviewed the pitch deck that we sent over previously, but at the highest level possible, we're an AI and IoT energy management firm. So we work with large energy consumers, tends to be industrial and some of your large commercial facilities, and we provide them solutions that help them reduce their costs, reduce their emissions, and reduce their downtime. So I've highlighted some of the more recognizable brands that we're currently working with across North America. So again, industrial folks like West Fraser, Stellantis, some more folks that fall into that commercial category, Cadillac Fairview, RBC, Sobeys. In terms of total customer profile, we're working with over 190 facilities across North America, and then we have one facility in Spain that we're supporting as well. That amounts to just under 1 gigawatt in terms of the load that we're working with. We're also a certified B Corp. So again, I feel like I'm preaching to the choir a little bit here. The energy transition is upon us, and obviously that has massive impacts. With the electrification that we're seeing to industrial systems, heating, transport, as well as the decarbonization of the grid, obviously the grid regulations and pricing structures are undergoing massive changes. And what we've seen is that industrial users are generally stuck in the past, and despite being a large input cost, energy is often an afterthought. So generally speaking, we can sort most of the customers who aren't leveraging some sort of Edgecom technology into 2 buckets. Either their energy data comes in the form of a monthly bill, so not very insightful, very high level, delayed by at least 30 days, or we have other folks who have invested in SCADA systems, which are antiquated, hard to use, and they maybe have 1 or 2 people on their team that can actually get the full value out of that system. So not user-friendly and not built to actually get the most bang for your buck. So as a result, we're seeing that large facilities on average waste 12 to 20% on energy every single month. Not only are they wasting more money, they're also emitting more CO2 than otherwise is required. So to act on that problem and really identify those savings and generate those savings, these facilities need a system that makes it really easy for them to gather that data. They need to be able to analyze that data in real time and then take control and change their operations based off the analysis that's being done with that data. So that's where Edgecom's platform comes in. Effectively, we've tried to make an integrated energy platform that serves as the connecting piece between what's happening within the facility and what's happening on the grid. So again, you guys are all familiar with the products. Effectively, again, data track, providing that visualization across every asset, every process, every machine. P-track, giving the forecast in terms of what's happening on the grid, indications of what's happening price, demand, and emission-wise. NeuroCharge, if you have DERs, we can dispatch those automatically. But really, the Copilot is kind of the crowning jewel and the core focus of this presentation here today. So again, a little more description here. You guys have all gone through them, but those are the 4 core elements in the different areas that they support. When we're coming down to the Copilot, effectively what we're looking to do is take an energy manager and train an AI to act as an energy manager. So removing all the historical analysis, the number crunching, the report generation, and letting customers spend less time looking at energy data and more time implementing the energy initiatives and the recommendations that our AI is able to identify. So again, for those less sophisticated customers, pointing them in the right direction. For the more sophisticated customers, taking all that data that they have, the massive amounts of data that's coming in real time, and turning that into intelligible and actionable insights. So one of the recommendations that's currently being pulled up on the screen here, effectively what we've done is created a 24-hour optimized production scheduler. So effectively, you can ask the Copilot and say, hey, I need to produce 500 kilograms of rubber ducks tomorrow. Tell me exactly how hard I should run my facility to minimize my emissions, minimize my costs, but still hit my production output. So again, this can take into account the priorities of the facility, the limitations, the interconnections between the machines, and tell you exactly how hard you need to be running each of those individual assets to reduce and optimize your cost as much as possible without impacting that manufacturing output at the end of the day. So taking into account internal and external information to optimize. Using that application, we were the winners of Shell's New Energy Challenge in 2024, ABB's Startup Challenge in 2024 as well. We participated in a couple cohorts with AWS and some other programs, but again, just kind of emphasizing the fact that this AI tool is getting buzz from some of the leading enterprises across the world. And that ABB challenge specifically is what resulted in us deploying that Copilot and that exact use case of the Copilot in a facility in Spain. So again, overall, the system that we're looking to develop here, it's an integrated energy and peak management system that grows with the customers as their need changes over time. So again, integrating as many of those energy solutions as possible into one platform so customers don't have to work with multiple different solution providers. And again, we're trying to integrate across a broad variety of areas. So again, the real-time analytics and the IoT, your traditional and your generative AI, your demand response aggregation, your peak energy prediction and your price predictions, as well as your DER optimization, all built into a single platform. So again, as a customer's needs change over time, we can provide additional services and everything's interoperable from level one. Just running a couple case studies here. Metrolinx, I guess this is kind of relevant to where you guys are meeting today. Regional Rail in Toronto, so that's one of our big customers. Again, just providing some background in terms of the results that we've been able to generate across a variety of different deployment settings. So again, whatever you want to call them, an infrastructure play, Bach North America, a plastic extruder. Again, just providing some of the hard stats in terms of what that benefit looks like. Again, same thing with some dairy companies. We also have partnerships existing with utilities currently. So we've got a partnership with NB Power out on the East Coast that's been very successful so far. And finally, when it comes down to our ask, we're looking to collaborate specifically with EDP, and we want to deploy our virtual energy manager eventually in every C&I facility across the Iberian Peninsula. So I've got some stats here in terms of what this potentially could look like, what that benefit is based off the information we have so far from that pilot facility, what the cost and what those next steps are. So on that note, I will shut up.
Yes, Tanner, I really feel that with the speed that you were saying, you said double the presentation, so you had 12 minutes to present. Very good, thank you. You can leave that slide with us to read, but let's go to questions right now.
Okay, thank you. Thank you, Tanner. I'm Masami from Jira. Thank you for a great pitch and congratulations on being on the list of the top 60. I have a couple of questions for you. So first one is, how do you differentiate your technology from other AI-based energy management systems?
So I think the largest differentiator is the fact that we're encompassing multiple different areas. So again, we're combining that engineering expertise with data science, AI, and certified energy managers all in one house. So again, there's a lot of companies that will compete with us on a pure IoT perspective, on a pure software energy management perspective, on the AI perspective, or on the asset dispatch. So coordinating that all into one platform means that we can serve a mid-sized manufacturing facility better than any of those individual kind of competitors.
Thank you. Thank you for the clear answer. So next one is, how do you plan to stay ahead of the technological advancements in the power industry?
Sorry, in the what industry?
How do you plan to stay ahead of the technology? So your technology is well developed right now, and how do you keep your position in the power industry?
I think the one key there is continuing to collaborate with other entities on a global scale. So I think then that will allow us to integrate kind of the best practices across multiple different regions and ensure that we're staying ahead again on that global scale. So the relationships that we've developed with ABB, Shell, LG, again, some of those more recognizable brands means that we have a lot of data coming in real time that enables us to stay ahead of the competition on multiple different levels. And again, combining that with the industrial base of customers that we built, we have a large data moat. So we kind of have a historic data moat as well as kind of that forward-looking information that'll help us stay ahead.
Thank you. Understood. So what strategic partners are in place to ensure market penetration? It's a similar question.
Yeah, and I think so. We've got partners on a whole bunch of different fronts there. Again, we've got some distributors who again have existing relationships that we can leverage to get deployed within existing facilities. So again, I think utilities are a prime example of that, and that's really why we're interested in the Free Electrons program here today. Just looking at folks who have some sort of vested interest and can also benefit from the services that we're providing, even if they're not directly within the customer site. So again, utilities, some of those corporate level collaborators, whether those are on a commercial or a joint research and development basis. Same thing exists with some of the universities that we're working with here in Ontario. I think there's a whole bunch of different players there that, again, help us get further connected into the industry and establish more connections directly with those facilities, which just ends up increasing our reach and traction.
Okay, I understand that you have started your business with a very good partnership with the industry partners. So what are the biggest challenges you are anticipating in expanding the product or services offering globally?
Globally, I think there's two issues. One, I think just based off the availability of programs, especially as you're looking into new markets, some of these concepts in terms of, volatile energy rates, demand response programs, peak management, they're relatively new. So the status quo has a strong hold, especially when you're looking at some of these more traditional industries like manufacturing. So I definitely think that's part of it. Kind of the second phase of that point is that, these programs are very difficult and dynamic to manage by nature. So scaling becomes difficult. So I think that's kind of, again, I don't think it impedes our growth, but it means that, again, we have to be reliant and kind of open to those partnerships so that we can get more specific market information to develop these products as soon as possible. And then again, leverage those existing relationships so we can overcome the status quo, whether we need to support pilots, prove out that ROI and that use case within specific markets. There's a couple different ways that we can tackle that.
Thank you, Tanner, as well. We have a question on our chat that we unfortunately don't have already time to, but it's about elaborating more on the your suggestion of the pilot with EDP. We will take it in a written form aside, so don't worry, you will get this question exactly. Thank you very much.
Thanks, everyone. Have a good one.
Really great to have you and your team. That's everything for today. Once more, thank you and have a good rest of the day. We will be in touch.
Thank you. Have a good one.
Thank you.
Andre.
Why is it not teaching to anything?
Andre is amazing.
I do good lobbying.
I know.
I just get left alone.
We are right now continuing the energy management data category. Also, we'll continue tomorrow. We have 2 more startups, Latence Technologies, and will join us. So you're here already.
Hello.
Welcome.
Yes. Thank you.
Great.
Thank you for having me.
Congratulations on behalf of everyone here on making this to the top 60 of Free Electrons 2025. We are very excited to get to know you and your solution. Whenever you are ready, please share your screen.
Okay.
You can start it. You will have 6 minutes for that.
Okay, let me know if you can see my screen. No?
Yes. Not yet a full screen, but
no? Okay.
Sharing.
But you can see I'm sharing my screen right now. Okay.
Yeah. Slideshow. It's in a full screen, but maybe try to click one more time or
yeah, I'll
share
take the
one.
Sure.
That's okay.
Okay, I think there was a little.
We can see.
There you go. Yeah, we can see it well despite the top part.
Yes, let me just maybe go back because I think it was lagging a bit. Okay, I'll come back in 1 minute. Okay, now does that work?
Yes.
Yeah, very good. Go ahead.
Great, you can see it in full screen and everything? All right.
Yes.
Sounds good. So hello, everyone. Welcome to Montreal, by the way. I'm very happy to be here today with you guys to introduce Latence Tech, our company, with this presentation on how to monitor and forecast low latency connectivity to power the future of energy. So this is what the world looks like today without electricity. Right? And this is what the world looks like today without connectivity. Why? Because connectivity is the new electricity. The more we connect devices, the more we rely on the network. And right now we are connecting everything. And utilities are no different. I'm sure with all the companies that you see today, most of new innovations require a good connectivity to work. This is why we bring our solution to the utility world, a 100% software solution that allows utility companies to monitor, forecast, improve the quality of their network to ensure reliable, safe, and energy efficient operations. Our software agents can be easily deployed on multiple locations in the network to gain full visibility from the network and the connected devices perspectives, so that there's no more being in the dark. Our clients love the fact that our solution gives them real-time analytics because it is what we need today. So no more relying on 5 minutes aggregated logs. We can not only monitor, but predict the quality of the network for the next 90 seconds, depending on different use cases, to take preventive measures. Our clients also like the fact that we can help them deploy a solution easily anywhere in the world. This is why companies have used our solution in Europe, South America, North America, and South Africa, and hopefully other countries. And finally, another great advantage is that we are network agnostic and work on any type of technology. This gives extra flexibility for large clients depending on a mix of Wi-Fi, 4G, 5G, LTE, satellite communication, and different vendors of telecom equipment, like we can take of Nokia, Huawei, Ericsson. We work on everything. So imagine a complete end-to-end visibility in real time on all infrastructure, every step of the way, even in remote locations, to build a smart and sustainable future with AI-powered connectivity is the key. If we focus more precisely on one specific use case, here is an example of a concrete POC we could work on. Real-time monitoring for the tele protection network with our software agents deployed in different locations in the network to ensure 100% reliability. Here's another example of a use case for power plant network surveillance, where we can deploy our software agents on different underground levels to support automations. We are actually currently working on a similar use case in the mining industry in Quebec. And it's not our first pilot. We're a team with extensive experience in developing successful POCs with key industry players. We've worked with Ericsson twice in the past, developing different projects, Orange as well in France, Orange Group, Misa Group here in the mining industry in Quebec, ArcelorMittal in France, and the little video that you can see here for autonomous vehicle application, Smart City with Pioneer, which is now Magna, and Ericsson in Gothenburg in Sweden. And not only do we have an experience in running successful pilots, we also have an experienced team of founders and advisors, as you can see here, with Bertrand Hébert here on the left, and our CEO, Benoit Gendron, that both have previous experience in working with Hydro-Québec here in Montreal. So we have hands-on experience on some of the utility challenges. So basically, after all of this, to tell you that we are ready to make a real impact. We have a perfect solution to pilot anywhere in the world with the right team to generate quick wins, but long-lasting impact. Our solution is easy to deploy and to test. It's 100% software, and it's a mature technology that we've tested on over 100 corporate networks. With our experienced team that is ready to bring value and adapt solutions to real problems. So at this point, let's start working on a real use case and figure out together where you need real-time visibility to build confidence and resilience in the network. Thank you. Ready for any questions?
Yes, we have 1 extra minute and we will right away move to questions.
Sounds good.
Yes, thank you, Chloe, and congratulations on making it to the top 63 Electrons. I'm Maxime Godin from Hydro-Québec. We have a few questions from our business units. Yep. First of all, what are the requirements for installing your agents on our IoT cellular devices? Can you install them on already built networks, already ground feed?
Yep. So requirements, so they're really light agents, so they're small, so it's around 20 to 40 megs. That's basically what you need. So it's a Docker container. I don't know if you're familiar with the Docker technology for packaging everything together. So that's what makes it really easy. So anything that can handle a Docker, basic Ubuntu, works pretty well. So depending on the different, devices that you have, it could be modems, but it could also be IoT. So we have to check for specific, devices you have in mind.
And how would your solution work in a private APN context? Meaning SIM card IP address is not rooted on the internet.
Yep. Well, we work on private networks, so this is not an issue. So we've done it for, in this industrial sector, so it doesn't have to be on public or with specific SIM cards. So we can connect directly to the private network. So our solution could be hosted completely, on premises with no access to internet, a completely isolated solution, or it can also be in a hybrid mode or cloud, depending on what you want. So it's pretty versatile in that aspect.
Okay, and last question for Hydro-Quebec. Following its analysis, can your solution provide recommendations? For example, who's the best ISP? Should we add booster here or there, or add remote directional antenna for better signal?
Yeah, very good question. So this is the step where we're at right now. So we can provide a few recommendations right now at this point. And then what we're working on is to enhance those recommendations with the use of Gen AI. So we're working on a pilot right now that will be starting in the next few months as well to enhance this feature and really make it more complete if we want. But we're starting to give, yes, recommendations on how to improve the network at this stage.
Okay, so I can leave the floor open for questions from other participants.
Yeah, can I have, yes, I have a question. Thank you for your presentation. Regarding question number 1, you mentioned that it's on containers. We need to install the agent. Can you specify any vendors currently you did work with as end devices aspect? I mean, do you have a
Cradle points, like modems like that, like Cradle Point, like Cisco,
Cradle Point.
Different types of device. I could send you maybe a list. We have a full list of the devices we already tested and we're compatible on. I'd say I don't have them all, top of mind right now, but I know these types of, typical network equipment we've tested already.
With Cradle Point, that's a good one.
Yeah,
okay.
Cradle Point already and some Cisco equipment as well. But yeah, I would have to check the specific models that we have. Yeah.
Okay, thank you. Interesting.
Any more questions?
One question. So some of the examples that you have presented are mostly around either substations or power plants. Do you have any projects working with wind parks or solar farms where connectivity, especially in remote places, can be a challenge? Do you have any project around these?
So not specifically for renewals, but for remote projects, this is a project that we have ongoing right now in the mining industry. So we're okay to work in a location where there's no internet. That's why we're also tested our solutions for satellite networks. So this way, that's usually what remote locations rely on. So we can do also this mix of technologies. So more in the mining industry, that's something we're testing right now because there's a lot of remote sites.
And one question, the monitoring part, I can fully understand, but then just with software, how does the optimization work? How do you increase the connectivity just with software?
Yes. So to actually be able to act on the equipment, we would have to partner with the equipment vendors. This is also an option that we're looking into. But right now, what we can do, that's why we discussed a bit the step of recommendation. So this is where we're at right now. So we're not going to act on the equipment or to actually make the antenna, flip or something like that. But we're going to give recommendations to the IT team to say, okay, where is the issue right now? We're going to segment it down to the actual location where we have an issue. We can know on which protocol, we can know what's going on. And then from there, give recommendations. But for now, we're not acting on the network itself. It's the next step.
Thank you.
Very good. We are on time. Allowing 10 minutes pass very quickly. Thank you, Matt.
Thank you very much for your time. It was very nice to see you all, and hopefully we can work together later on. Thank you.
Exactly. Thank you. Have a good rest of the day. Bye-bye.
Thank you, you too. Bye-bye.
You can click here on the bottom right, there is a button to leave the room. Okay, that's it. Go. Very good. We are going to the last startup that is ready. xMap AI. And we are welcoming everybody. Hello.
Hi.
Hello, hi. Good morning, right?
Actually, you're expecting my colleagues, Mo, who is in Japan right now, but lucky enough, I'm in Canada, though. So, meet you.
Okay. I must say that when doing the schedule, you were the first one to put on the map because Japan was the hardest to fit in. But okay, we're here now. Great to have you. Welcome and congratulations on being on the top 60 of Free Electrons 2025. We are all here in the room, more than 30 people ready to get to know your solution. So I can see your screen. And whenever you're ready, please start. You have 6 minutes for that.
Okay, perfect. Thank you. And thank you so much for the invitation. Very happy to be here. Next time, hopefully, I can be there physically. So we are xMap. We are a generative AI platform designed especially for geospatial data. Think about something like ChatGPT with Google Maps, where you can drop here a polygon, draw a polygon here in the map, and start asking questions about it. So doing this, it significantly increased the speed of consultants and people who are searching for different information to analyze it using this type of generative AI. So what you do, so basically you can draw here a polygon in the map, and you can start asking questions like, is that a good place for a gas station? Or how many cars passing by? We have like GPS car feed from that, and we can analyze this as well. You can also ask a question like, how many 3-star hotels are around, or is it a good place for 3-star hotels? Can I land a helicopter here? Or is the price going to increase in this area using the analysis for the real estate pricing? So basically think about any type of information that you're searching for, and you can analyze this by looking to the map. So how it works, 3 simple steps. First of all, you can draw the polygon on the map. Then you can ask the question from here. You can type it or you can speak it. And then you can simply get the answer. So how the technology itself works, of course, you have here the LLMs, the well-known LLMs that you have things like, I would say, OpenAI, ChatGPT, or DeepSeek, or Gemini, or any of those LLMs. On top of that, we are building our small language model or specialized language model designed specifically to speak with geospatial data. On top of that, you have a lot of data layers that we are analyzing. For instance, you have the competitor data that you're searching for, like restaurants, cafes, bakery, and all of that. You have the traffic information around you. You have the access, you have the demographics, and you have tons of data that we treated as layers. And then when you ask your question, our models will search the data tables that we have for those type of answers and give you a specific answer based on that. During the past period, we have been engaged with different startup incubator accelerators around the world, including 500, Google, Alchemist, Stanford StartX, Hub 71 in the UAE. And recently, we started having a program in Canada as well with Beehive. And we started to be engaged also in different grants and applications with the Ontario Centre of Innovation and Oven. So about that, we won several awards. We got from Google and from Alchemist in Japan as well, and from Pitch Tokyo. And our technology is able to be applied in different industries. As you can see here, you have food and beverage, you have marketing, and healthcare, and so on. So we have several clients, but the majority of them, we can see the value within the consulting industry, where we have all the consulting companies like Deloitte, McKinsey, Ernst & Young, and everything. At least they have one team is using xMap right now. Even for Deloitte, we do have like some specialized platform for them where the Deloitte consultants can use it in order to analyze the geospatial data. Some of our large clients would be Unilever, for instance, and we have JLL, Roland Berger, Coca-Cola. And all of those, they are using the platform in order to understand more about the market that they are operating in. Later stage, we're very happy to share with you more of this information about our success stories with funds like the Public Investment Fund in Saudi Arabia, where they are using the platform to take investment decisions, Bain & Company, Unilever, Coca-Cola, and many more. About the team of xMap, we have Mo Batran, who's the CEO of the company. He has master's degree in a similar field from University of Tokyo. All the founders, by the way, are like living in Japan for the past 10 years. And we have also Ayman, who's the CTO from experience from Rakuten and Mercari, top Japanese companies. Myself, my name is Fareed. I'm the COO of the company, and I had experience before as a professor in the area of entrepreneurship and innovation in different consulting projects with JICA, WHO, United Nations, and many more. And also we have the head of R&D, Yassine, who's also a senior data scientist and has an experience working with the Japanese government in something related. Thank you so much for your time and looking forward for your questions.
Very good, Fareed. Thank you very much. We have some extra time. Let's move to questions.
Perfect. Hi, Fareed. This is Samuel from Eon. Congrats for making it to the top 60. Very good to have you here. My first question would be, in which markets you can already offer your solution? Because you showed like there are these different data layers you need to ingest in your solution. And I have a question mark, how many of these data layers are actually available on our different markets, especially, of course, the German market here?
Yeah, so at the moment, we do have the data of the POI, let's say the POI or point of interest worldwide. So we have more than 200 million points, if I remember correctly, more than 200 million points worldwide. For the traffic data, we have partnership with Here Maps, which is the top provider for that, and we have access to it worldwide as well. For the demographics information, we have it worldwide as well. So in terms of the data ability that we have across different regions, yeah, we have it worldwide. However, the rollout of the model, we do it step by step, city to city, because it takes time for us to train the model and check the answers and get to know from the replies of the people how frustrated they are, or if the model needs to be retrained to take care of a specific region or function. So, so far, we have deployed this model in Saudi Arabia, in United States, and in Japan. In Japan, where the main company is, we have also very big enterprise clients, such as Rakuten, for instance, who have a special instance of this software, like white label, used to select sites for their shops and being used inside their facilities. Step by step, we are getting this to more countries. So right now, our next focus will be Canada, since that we already started to get like some foot traffic here in Canada. We passed the initial stage of a project with OCI with the Windsor Detroit Tunnel to use this kind of software, and we are still in the middle of the application, but we passed the initial stage. So the next step is Canada, and if there's another geography that we will be focusing more on during the upcoming period, would be the Middle East region, more like Saudi Arabia, United Arab Emirates, Qatar, and so on and so forth, where we can see that this technology is kind of new there, and we would like to boost the innovation in this region.
Thanks a lot for the extended answer. I would be curious, like, how sure can I be that the information I get are actually true? Yeah, because we all know from ChatGPT and so on this problem of hallucinations.
Yeah.
If I base my investment decision on a certain location on information which are not super 100% solid, that would be a problem.
Yeah, that's a very good question. That's actually reflects your deep understanding for the industry. So thank you so much for that. So for this, like models like ChatGPT and so on, as you know, it's like generative. So basically, if they don't know, they will never say that we don't know, but they will basically generate a new answer, right? In our case, it's not. So in our case, it's tied with X and Y. So when you do the polygon here, for instance, when you draw the polygon here, we transfer this to an X and Y, then a well-known text, and we know exactly which region that you are searching for. And based on that, we start analyzing our data tables that we have here, similar technology to the RAG, or retrieval augmented generation. So we start searching for the data tables, and if our models, if we don't know the answer, we clearly say that this information is not in our data table, but we don't generate any kind of new information or anything like that.
Okay. Can you show the data sources?
Sorry?
Can you show the data sources? If you give me an answer, can you show me where the information is coming from?
Yeah, of course. Would you like to see it, how it works? Like a demo?
I mean, right now, like if I'm a user using your interface, and I got an answer from your software, that would be interesting to see on which report, on which database this information is based on.
This is, of course, this is private information because it's related to how we train the model itself. But like if you're inside the company, yes, of course, I would be happy to show you like how the model works and which table it's linked to. But we don't show the user the actual table where the data is coming from, because if so, the user will be able maybe to do data crawling or downloading the data, which we will lose our competitive edge. But of course, we have everything mapped out.
There is one more
Did I
very
get
interesting
the question correctly? I'm not sure. To be honest, the voice is a little bit hard to hear, but I hope I got the question correctly.
Yes. Farid, there is one more very interesting question, but we really passed time, so I will get it to you in a written form. It's in the chat, very interesting to tell a little bit of the use cases that utility companies could find with your company. But think about this, if you have anything, send it to us, we will pass it, but we need to take it offline. 10 minutes passed very quickly. Thank you very much for your presentation.
Thank you. Thank you so much. And hopefully next time I will be there in person, right?
Yeah.
By the way, I understand that you're in Waterloo. My first hockey game ever, like my first hockey game to watch ever in my life, was actually in Kitchener. So this is where I watched it, like my first hockey game in my life, right? So yeah, next time I will be there. Thank you. Bye.
Thank you. Goodbye, Farid. And he's gone.
The fade going the other way. The fade is the.